A very good morning to all of you present here. So it's a pleasant welcoming you all for this e-Yantra Symposium. So we have been having the Women in Robotics workshop for the past 2 days, as well as the ELSI Summit for the e-Yantra community faculty members. And today it's a culmination of all these together where we welcome the interns, the faculty members, as well as the Women in Robotics participants. And it's also the ceremony where we celebrate our interns who had come through the e-Yantra competitions. So we have the summer internship exhibition as well today. So without much ado, I invite Professor Shivram Kalyanakrishnan, Principal Investigator e-Yantra, to address the gathering.
It's always very comforting to get the applause before one starts talking. You don't know after one finishes whether you're going to get it or not. But anyway, good morning to all of you. I think I've been doing welcomes day before yesterday, and today it's the same welcome. Instead of saying very warm welcome, I say very rainy welcome to IIT Bombay and to this event. Particularly, I'm curious, anyone has traveled from outside campus today? Good number of you, so especially hearty welcome to you, because I don't know if you saw it or not, there's a red alert, okay? It's been raining very heavily, so glad you got here and take care. As Veena said, today is actually the culmination of multiple events that have been going on over the last 3 days, but also last whole year, you can say. So I'll briefly introduce the 3 groups which are sitting here. I don't know if you've already interacted with each other. Foremost is our summer interns. There are about 100 of them. You can give them a round of applause. So, yeah, e-Yantra has this annual cycle of events, one of which is the e-Yantra robotics competition. We also have the Innovation Challenge, EYIC, and typically it is from these two sort of events that we pick our interns. Our interns came here about a couple of months back. In fact, they're going to finish by the end of this coming week. A 10-week internship, and yeah, whoever has sort of been in our department for the last couple of months would have seen interns flitting around, carrying things, flying drones and all of that. So you've given a lot of excitement, enthusiasm around the department, so thanks. And for the others, this afternoon we're going to have a exhibition of the interns' work over the summer. There's posters, there's also like live demos that they will be doing, so do stay back for that. Okay, so interns is one population. The other cohort is students, 100 plus students again, who are attending Women in Robotics event that we decided to conduct. So actually it's very simple. It's something that has been there in front of our eyes, but we've chosen to treat as normal. So the gender ratio in nature is 1:1. Okay, the gender ratio in robotics, right, has been something that is a far cry from that. Maybe we've had 1 girl for every 20 boys, sometimes 1 for every 10. So this is something that e-Yantra took note and wanted to do something about. So in the last 1 year, we've tried to particularly bring in more participation from women. So we were very overwhelmed by the response we got for this first of a kind workshop that we conducted last few days. So we have, I think, 100 plus students, a lot from Maharashtra, some also from other parts of the country who've come for this, and we hope that this will be a beginning, right, that will then prompt more and more girls to take part in robotics and related areas. So warm welcome to girls who've come here for the Women in Robotics workshop. Another round of applause. All right, so it was oversubscribed, okay, so I think we had 600 applications. We were only able to entertain about 100 plus because, I mean, there's constraints on hostel and things like that on campus. The third cohort, which is here, okay, is a group of faculty, okay, instructors from various colleges. As some of you will know, e-Yantra has a big network of labs, okay, there's about 600 e-Yantra labs in corners across the country. And from all of these, not all of these, like a good number of these, we have faculty who are visiting here. So all of us reside in this ever-changing landscape. Okay, every time you kind of figure out how to do something, right? I don't know, like COVID comes or AI comes, something comes, right, and churns up the whole thing. So it's a constant endeavor to try and understand what the challenge is, how to navigate, right, work on this problem of bringing up the human resource in the country. And particularly now, I think Kavi is the one who told me the statistic. I think more than half our population is under the age of 30. Okay, that includes most of you. So we have a huge demographic dividend, and it's in, I don't know, from an economic standpoint, the country's interest to make sure everybody is well equipped, right, to navigate their careers and futures and so on. So of course, for that, it's not a scalable model for a small group sitting here in Mumbai. e-Yantra also has a small center in Chennai. To handle all of it, we do need the support of a much broader network. That is the faculty, right, at different e-Yantra labs across the country who've been helping them. So third round of applause, please. All right. So as I said, there is always challenges, and frankly, nobody really knows, right, how to solve, right, what's coming next. So we sort of put our best foot forward in terms of understanding how to, I don't know, bring changes into education, right, what technologies to go after and so on. But there's actually something that came to my mind as literally I was walking in this morning. Okay, I didn't plan to say this to you, but I thought it is very relevant. So one of the things that e-Yantra wants to achieve, given really the vastness and diversity of the country, is to enable people to solve problems in their own local ecosystems. Now this is because, I mean, somebody living in an area knows best, right, what the constraints are, what the available resources are, right, what the cultural maybe situation is. Now I remember going to Baramati, right, sometime back, and we were talking about agriculture and drones, right. We said you should be using drones for applying fertilizer, and then the farmers all looked at each other and laughed and said, it's close to an airport, so this is a no-fly zone. We can't fly drones over here, right? So there are small, simple things like this that we don't know. The particular incident that triggered me off this morning, I mean, of course, it's raining very heavily. I don't live very far away. I live on campus, okay? I was walking to work, and then at one point of time, right, I just put my umbrella down and heaved a sigh of relief. Can somebody think when that might have been? Was it when I entered this building? It was when I entered the infinite corridor, okay, the walkway, which made me think, right, I don't know if you know the history of this, but when IIT Bombay was built in the 1950s, right, at that time, right, it was decided that there would be this corridor, right, enclosed corridor. You can see that it connects most of the older departments. There's chemistry and physics, this side there's mechanical and so on, right. So computer science, I think, came a little bit afterwards, but you can pretty much walk from any department to any department through the infinite corridor, which makes so much sense, right. There is 4 months of rain, in Mumbai, and I think this is like an excellent example of foresight in engineering and design. Okay, so much so that we take it for granted. It saves so much trouble. You can contrast that with where many of the interns have been plying, the CC building. Yes, have you noticed anything around the CC building? There's a lot of civil work going on. So my office for me was out of bounds for the last couple of weeks. Why? There's a leak. Okay, every time the rains come, we find some new leak and we go start fixing it. And I don't know the truth of this, but from what I've heard, the building was designed by an architect who came from New Delhi, okay, who kind of failed to take into account that there's 4 months of rains in Mumbai. Okay, so this for me, I think, is an example that people who are in charge of engineering systems, right, must be ones ideally from the local environment who's going to use that technology. And the fact that we have I don't know, all of you from all over, right, who are here, of course, for these 3 days, but are then going to go back. We hope more and more of that should be happening. We should make in India, right? We should be doing engineering for our own needs. So anyway, so today the culmination of the e-Yantra Symposium gives us a time both to look forward and to reflect, look back at what has happened. So I wholeheartedly welcome all of you. I would take this opportunity to also bring into focus that e-Yantra, I mean, many of you know it as e-Yantra, but we're a project, okay, like many other projects that are running at IIT Bombay. An e-Yantra project runs out of the Department of Computer Science and Engineering, okay, where I'm a faculty member. So was Kavi till he retired last year. And I mean, we take it for granted, right, when we need any sort of support, right, it is the department that provides it. to us. e-Yantra lab is right next to the department office. I mean, all of you are sitting in labs that are actually like departmental labs. Department has been an infinite source of support, strength, right? And we're very happy that today here we have with us the head of the Department of Computer Science and Engineering, Professor Uday Kedkar. So I would like Uday to please come and address the three groups over here, right? And thank you. Right before I hand it over to him for all the department has been doing to us, but what does e-Yantra mean for the department, right? And maybe you can say a few words.
Thank you very much, Shivram. It's a pleasure and a privilege to be here. As I walked in, I sensed a lot of energy in this room, and that is something that e-Yantra definitely brings to the things that the department does. Very nice to see all of you here. I'm sure in this crowd, at least some of you are feeling that you're being greeted by the wrong kind of persons. One of them has all gray hair, the other is on the verge of losing all the hair. But still, I will take the advantage of my gray hair and pass off as a wise man. I know internally that is not true, but let's pretend for a while that I'm a wise man and I'm trying to tell you some things. So one of the things that you would have noticed that e-Yantra brings, and which is what IIT Bombay stands for, is a sense of quality. Very often we go for brand names and we forget the value that the brand names bring. Many people look forward to IIT because it is IIT. Many people appreciate IIT because maybe our students get very good pay packages. Many people appreciate IIT because other people appreciate IIT. But what does IIT stand for? That is something that not many people care to look for very deeply, and that's what I would like to remind you. It is a sense of quality. It is a good sense of quality. If you can understand good sense of quality, if you can distinguish between what is good quality and what is not such a good quality, then your life will become very, very beautiful. This quality could be in the robotics projects that you do. This quality could be in the story that you write, the poem that you write, or the lecture that you attend, or the project report that you write. This quality could be in anything. But a sense of quality and an appreciation of quality, in my opinion, is the first and the foremost requirement of excelling in whatever you do. And it is my earnest request to all the faculty members gathering here, please make it a point to bring this quality to the notice of the students. Unless they sense the quality, they might just go for the labels, and that is where they will lose. They will lose the opportunity, they will miss the opportunity of learning what we expect them to learn. You would have noticed e-Yantra stands for quality. The kind of projects that students do, and it's not just the kind of project, just think of the vision behind the whole project. Think of the organization that goes in. Just imagine arranging this event, providing facilities to so many different colleges, selecting students, enthusiastic students from all over the country, bringing them here, making their arrangement of stay, making it comfortable for them, and doing something whereby they go back with a strong message of doing what they find interesting, doing something challenging. That is, behind that is a great sense of quality. So that is my only message to you, suggestion to you. And with that message, I once again welcome you to IIT Bombay. I'm very happy that all of you are here, and I'm very hopeful that you will go back with whatever quality you have witnessed around it, or absence of quality, as Shivram pointed out, in the CC building where we have leakage of rooms. So being able to distinguish between these is something very, very important. So thank you very much, and welcome to IIT Bombay, and enjoy your stays. For some of you, the stay may end soon. I think for all of them, right? So I hope all of you have enjoyed your stay. And I look forward to seeing most of you back here as master's students, as MTech or MS or PhD students. we are always in lookout of good and enthusiastic students like you. So when you go out, please don't forget us. Please try to put in efforts so that next year I or whoever is the head next year can welcome you as a member of IIT Bombay fraternity. Thank you very much.
Thanks, Uday. At this point, I'm going to invite the founder of e-Yantra, okay, who had this idea many, many years back to start it and who's really sustained it for so long, to please come and share a few of his thoughts with us. Please welcome Kavi Arya. Doesn't work. There's been an issue today.
So let me just contextualize. I'm really proud that Shivram, my colleague here, has taken over the mantle of e-Yantra. I was in great tension the last few years because what we built is quite amazing, and it needed somebody with the right spirit and the right atma, if you like, to take it over. And I felt very much like a father who's giving his daughter in marriage to somebody. Right? You want the person to be the right sort. And when I gave it in his hands, I was so relieved. And I've seen that he's brought so much josh and energy into the project. Like, this idea was fantastic, that you have this women in engineering workshop for 3 days and bring talented young women here to IIT Bombay and regale them with what we do. Because many a time we kind of limit ourselves, and I've kept saying to everybody here that most of the limits that we experience in life are not really out there. They're actually inside our heads. They're the limits that we hold inside ourselves. And until you start pushing against those things, you don't realize who you really are. And I think one thing that e-Yantra can take the credit for a little bit is that by showing you a mirror and giving you a platform where you can discover who you really are by pushing against your limits. And we are kind of cheering you on. And it's amazing what people are able to do when they are given the right mahal, the right environment in which to express themselves. And when you see the projects this afternoon, 2 to 5 we have the project exhibition, which are these interns, second and third year, most of them, first year and fourth year also. But each of the projects has been done in 6 to 8 weeks. And how would you compare them with the MTech projects at IIT Bombay? Right? It's pretty interesting, let's put it this way. Okay, it's amazing how much you've achieved in the project itself. And it shows that even 6 weeks of very focused attention can deliver you amazing results. And this is not for free, because you worked pretty hard 6 months to 8 months mastering all the technologies and all that we've exposed you to. And then we've taken you to the next level here. So this will be an eye-opener for all the faculty who've come from other colleges, who don't really know e-Yantra that well, to see what kind of project students can do in 6 weeks. Now, if you can make them do this in 1 year, it'll be a huge achievement, right? So this will give you, contextualize the kind of things that we want to do. Okay. So while we are waiting for our Associate Dean R&D, Professor Leena Vachani, to come, I'll tell you a little bit more about what we've been doing here. So the internship that we've had, right, our entire thinking is that we believe that you guys are the future technology leaders of tomorrow. You might not believe it yourself, but we believe that you have the capability of being that. And not only will you take leadership positions in organizations that you join very, very fast, but I feel that you also have the capability of doing startups, and we treat you as such. And then we find that when we treat you as such, you actually become that way, right? So actually this afternoon I'm off to Coimbatore, because one of our interns like yourself joined us, took part in the competition in 2012. He comes from a non-business background, middle class, Coimbatore. He was at PSG Tech College. His name is Muthu Vangaliyappan, you can look him up. He came to the finals, came to the internship in 2012 and did a project, and we had a 5-day workshop on entrepreneurship, which showed that you don't have to be an Agarwal or a Bansal to be or a Shetty to be an entrepreneur. Entrepreneur is a skill which can be learnt. entrepreneurship, right? It's a skill, it's a muscle that we don't exercise because nobody tells us it even exists in the first place. It's only when we go to America that we discover it, or Europe, right? Why don't you discover it here? So Muthu was very enthused after this workshop. And he said, sir, I want to do startup. I said, great. Promise me that when you leave and go back, you won't do a job and you'll either do a postgraduate degree or a startup because you create lots of value in these things, okay? So goes back, 1 year later, he takes up a job with Bosch. For 2 years, he works with Bosch. Then he leaves Bosch and does a startup called Catamaran Robotics. He was soon building mobile security robots for companies in Singapore. He was doing bellboy robots for 7-star hotels in Singapore, and now I went recently, he's changed his name to Goat Robotics. And only afterwards I discovered what GOAT means, right? You guys know because you're Gen Z, but I didn't know, okay? Greatest of all time, right? Robotics. And there was a huge exhibition at NESCO here at the exhibition grounds in Goregaon in March. I went there. Amongst the biggest stalls there was GOAT Robotics, who's doing automated solutions for logistics and warehousing and all that. He's got autonomous forklift trucks and all that doing all the work. And he's got his own operating system which he's built. Okay. So it so happens that this afternoon, I won't be there for the entire afternoon because I'm going off to Coimbatore. He's moving into a 30,000 square foot office in Coimbatore, growing at a very fast pace. And we're very proud of these stories. And there are a number of these kind of stories. So it just showed us that if you just tell somebody that you can do something, very often you might get surprised. They'll damn well go and do it. And that is the energy that all of you represent. That's the people in this room. But the same thing is represented by all the other youngsters who are there around in the country. So one of the things that I'm going to do with you guys while you are here is to see how we can together energize and inspire other young people apart from ourselves. Right? Like for instance, the projects that you've done here, there are 39 very good projects which are here at IIT Bombay. I suggest you go back to your college and do an exhibition there itself and give a talk about what you did to inspire other kids that they can do exactly the same. Right? We find that in the competitions that we run, it's actually a training program. It's like a hardware MOOC. Right? It's like you're giving a banquet, but you can't seem to get the word out. We can easily take 10 times the number of students who take part in the competition. At the moment it is 15,000. We can take 1.5 lakh students. We can take even more. I would say challenge us by more of you guys registering, and we can deal with scale. We've got an indigenous system which can deal with scale. Right? e-Yantra is quite exceptional in that sense. Like I was saying that I've discovered only after retiring who we really are, right? Because I've had time to contemplate. And we realize that e-Yantra rests on 4 pillars, and it's a totally indigenous invention as to how to create engineers at scale. The first pillar is doing meaningful engineering, means engineering which actually solves a problem. So we are inspired in all our exercises, assignments and all that by problems that are meaningful in society. Okay. Number 1, meaningful problems. Number 2, there's a mentorship program built into e-Yantra. So wherever you have an e-Yantra lab, you're finding senior students training junior students. So first the pipeline is primed by the student taking part in EYRC or EYIC. They learn some skills. Then what happens in a college which is proactive is that these skills, seniors are training the juniors. But it's very important that they have proactive faculty who are encouraging and mentoring also. So seniors are training juniors. So with the result that that lab is becoming a center of innovation and, cool things are happening. Students are not buying projects anymore from outside, BE projects. They're going out into industry, looking for problems, solving them in the lab. So that's the second thing. The first was meaningful engineering. The other is mentorship. And if you look at any space, any discipline which is nuanced, whether it is accounting, whether it is law, whether it is plumbing, carpentry, medicine, whatever it is, right? You don't have classroom education only. You have on-the-job education, right? You have You have mentorship models. When you go to a Bharatanatyam class, you go there and you are trained by a senior student, not by the guru. They ghisao you, that this is the form, keep on practicing, and through practicing you learn. And then the guru comes now and then and gives you the meta idea of things, this is how to do stagecraft, and these are the stories from mythology, and this is what you should believe and feel when you're doing these forms, and then you become a dancer. Would you employ a carpenter in your house if that person has been trained the way you are trained as engineers? Would you? With very little practical exposure. You wouldn't, right? So that's what e-Yantra is actually trying to bring back into engineering education. And we've deliberately kept ourselves out of the mainstream, right? Deliberately, because we don't want to be constrained by statutory that, that you are only allowed to teach this, only allowed to do that. This way we can pick up interesting technology from outside, and 2 months we'll put it down into a workshop or the competition and train you in those skills. Because we feel that we are training you in skills which will be needed maybe now, but 5 years later also. So now the emphasis has gone from embedded systems to automation and AI. And we have just the right guy here to bring you into that space, because I don't know how many of you have been introduced formally, but I have to read it out actually, the details of it. So Shivram is basically a researcher in AI, and he builds agents, intelligent agents that learn, spanning reinforcement learning, sequential decision making, multi-armed bandits and all that. It sounds very exotic. And humanoid robotics. And these things have applications in robo-soccer, in computer games and all that. So I feel that going ahead in future, e-Yantra could even change its model by entertaining things like robo-soccer, humanoid wrestling. You never know what he can do tomorrow, right? And it should be pretty exciting. And in the meantime, we've been joined by another colleague from Oxford University, Nived Chebrulu, who's an expert in robotics, core robotics and SLAM and all these kind of things. So Shivram himself did his BTech at IIT Madras, then his PhD at UT in Texas, Austin, and then he was with Yahoo Research Labs in Bangalore. And interestingly, he was amongst AI's 10 to watch by IEEE Intelligent Systems. This was almost a decade ago, right? Yeah? So apart from that, he's been a member of the 2015 study panel of Stanford's 100-year study on AI. So before we continue, Shivram, I would like you to just talk about this 100-year study of AI that you did a decade ago and tell us whether this is what you predicted. That's why I'm telling you, don't believe anybody what they say, right? Academics might think they know everything, but they don't, because when ideas get out there, they take a life of their own and do really cool stuff, right? So without much ado, while I'm here, we have our opening speaker. We are the opening batsman this morning. That's you, Lena. And she's a woman, right? But that's immaterial. She's a professor and associate dean of R&D. That means all our outward-facing activities that happen, research with industry and through government grants and all that. So all our e-Yantra expenditure comes through her office, and whether she is kind enough to entertain these kind of things, And so we owe a lot to her. So big hand for her, to her and her office for supporting us for the last 15 years. And she's been watching what we've been doing. So she's a PhD in robotic path planning and embedded systems from IIT Madras years ago. And she's originally an MS from ME in microprocessor systems from MS University in Baroda. And not everybody here necessarily needs to come from IIT Bombay or IIT Madras or the IIT system. She's an exemplar of someone who's come from a good university outside and done really well in the IIT system. And her research experience has been in autonomous robotics, path planning, embedded control, and more important, she's leading the underwater robotics initiative, which I hope she'll speak about at IIT Bombay. So lots of experience and lots of cool things done in her time. So with a big hand to Professor Leena Vachani for opening the session.
Thank you very much, and I'm extremely sorry for your delayed sessions. And many thanks to Professor Kavirarya for, exaggerating on my role. It's all Professor Kavirarya, Professor Shivram, and others in the computer science department who have brought the e-Yantra to this level. It's their persistent efforts, their passion. It's their persistent efforts and passion which has come to this level that we are meeting today. Shall I connect? This one, sir. Full screen? This full screen? Okay, I'll try keeping you can prompt me. So, okay. So, I have very limited time. What I am going to cover is the embedded control and robotics and my journey towards it. All right. So, once we start looking from the robotics side of it, what we have are different blocks, right? There comes the robot in itself, there comes the motion planning and control, there are actions, observations that mixed together makes a mission for it. So where we have been contributing towards it is various different kinds of mobile robots, not the humanoid ones or the legged ones, but say aerial vehicles, mobile vehicles, underwater vehicles, and then my spherical robot that I have developed yet. So what comes common in it is of course the control, right? So how can we make sure that something which we have designed for some particular system can also go into other system? I'm also from systems and control, so I look from the perspective of the systems, its subsystems, and then its interlinkages too. So that's how I've been contributing to. I look from the perspective that, okay, if my robot is just this robot, there's no other compute available, there's nothing else, so how do I solve the problems? So there comes the embedded platform selections. So there we have been using FPGAs, microcontrollers, and embedded Linux. Some of it you might have already used it in your e-Yantra tutorials and competitions. There comes the suite of sensors, right? Now there are vision, ultrasonic sensors, and then LiDAR, which could go even nodding kind of it so that I get a 3D picture of it. There comes, now we have all kinds of navigational sensors also on the robot. So then we thought, okay, why not we use the mobile phone itself on the robot such that we should be able to do my navigational task. So there comes my COTS-based designs. Of course, what is not there in the mobile phone is the depth sensing. So how do I solve my problems? So such kind of constraints we have to spell out while defining the problems. Of course, we have been using open source simulators like ROS, Sumo, datasets, various different datasets. Some examples you'll get to see here. And then when we have to design our problem suite, what do we need to say? We have to say whether I'm looking into, say, for example, multi-agent systems, single system, or whatnot. So is this system consisting of heterogeneous or homogeneous agents? Is there environment representation available? Is it a grid-based environment? Is it a landmark-based environment? Or any other thing that I should be looking at? It's a graph representation or a grid representation to say so. Then we have control methodology to decide whether it is decentralized, distributed, or centralized distribution, centralized kind of a control. And then comes the feedback. How am I going to get the state information? Is it learned, is it estimated, or is it directly measured? Right? So this kind of problem description helps me to define a mission or a particular bigger problem which I want to try and look from the perspective of robotic application. Where does it fit? Sometimes it's top-down driven, sometimes it is bottom-up driven. What is available to me and what it can solve is something we have to describe it well in such scenarios. There comes learning. So learning and control mixed, we'll talk about that. What is my overall objective? Am I making optimal planning? Am I giving guarantees on a completion? Or something similar, right? So that's all. And of course now, neither sensor nor actuator or not the entire system is going to be completely available to me all the time. So am I making a fault tolerant system? Something goes bad. Am I able to say something in uncertain scenarios that what is the guarantee I'll be able to do? Of course, the performance is going to be degraded, but by how much, right? So such kind of simple, any complicated scenario can be described in a very simple kind of things, and let's see how do we contribute to it. So in terms of the multi-agent collaborative applications, let's see, I mean, I'll show certain videos only today. If it's an edge computing, for example, mobile robots are moving in a maze kind of an environment and trying to make a mapping operation. So it is exploring. So what is needed is the resource allocation such that they are not kind of talking. So right now they are not talking to each other, but there is some method they communicate the least amount of information, because that is something also very important for me to consider if the communication is available to them or not. In an indoor environment may not be. So the most important answer that I have to give is, when do I say that the exploration is complete? When each of them are independently doing it, isn't it? So somewhere, wherever the map is being merged, somewhere in the map itself I have to encode it that the map is complete. That becomes some kind of guarantee to be given, and asking the robots to go in different directions. Okay, this kind of environment is not completed, go and again check there, right? And if it is there, then each robot should have its own map, and there should be some kind of a map consistency. Now what did I do here? It's a coverage task. Multiple robots are moving around a reference trajectory. And what is that reference trajectory? It's Lissajous figures, isn't it? So we have studied in physics, if in x direction there is a sinusoid, y direction there is a sinusoid, there is some kind of a sinusoid, some kind of Lissajous figures that give. We used to find the frequency of the signal in our physics experiment there. So that's exactly what, because my differential drive robot is now able to do the velocities in x direction and y directions. That's what we implemented there. And if they are now spaced equally along that trajectory, then they form wonderful patterns. Yeah? They are not communicating to each other, they are just doing the collision avoidance with each other. Here comes the SOM aggregation. A lot of mathematical guarantees go there when we talk about the SOM aggregation. SOM is coming here, especially when they are not communicating to each other. So just by local sensing, whatever the field of view is available, 120-degree field of view available, can they go to a particular target automatically? So they cluster it. So then this kind of motivation came from how honeybees do it. Not all of them may be able to go, and so that's how the control law is being. Control law is such that you are able to do it on your Arduino board itself. It doesn't do a great compute, but it brings in a lot of stability guarantees from the control perspective, saying that if things are perturbed, then also my things are going to work. If there is another obstacle comes in, I'm not changing anything into my control because they are already doing inter-agent collision avoidance. Okay, they'll be able to do the collision avoidance with static obstacles too, or anything that comes into their sensing. That's how even we human beings also do it, isn't it? We don't plan so much. So that's how the motivations can be presented. This is another work that we did with DRDO, which is priority patrolling. When the patrolling cars are to be planned such that there are certain nodes, certain junctions which are to be prioritized, they need to be patrolled at regular intervals while we are doing something random exploration, random patrolling there. It is on the graph now, it's not on the grid, right? The second thing important here is that the introducer should not be able to hack the path. If it's a regular path, then somebody will be able to know, okay, patrolling car is going from this junction to the next junction in the next moment, so I should go rather in the backside of it. So such guarantees are important when we have to present the high level decision making. Right, this is FPGA based collision avoidance. Everything, the collision avoidance in itself is doing its job with just the digital computations. So even with the smallest computation, you will be able to you will be able to solve the bigger problems, right? So, but of course there needs to be a certain backing while giving the guarantees and so on. All right. So here comes the question: when to control and when to learn, right? Of course, some part of it I have not shown the AI side of it or the learning side of it. We've been doing all control, isn't it? Yeah, but at the same time, we ourselves sometimes do control and sometimes do learning, isn't it? When we have started walking, we learned, but now I know this is my pattern, so I'm controlling my pattern. But so what has happened? Any uncertain environment that has come, which my control is not ready to do it, I am banking on my learning. While if I know that this model is available, things are available, things are known to me, I can offload my job to control. So that's where we can look forward for designing the hierarchy, what part should be done with the help of control and what should be done. So even in the smallest differential drive robot, what we have, the motors, and then there is a small PID sitting there. We don't touch and try doing it with the learning method there. We say, okay, PID control, PI control is just working fine. Why do we disturb that for the motor control? But when it comes to connecting these two motors, again, differential drive robot, models are available. I'm just giving one kind of a robot example. The other robot examples are also, some way physics has been drawn. We have understood it well over the years. Then control is a solution, where we can give guarantees. Learning, we still have to, deal with, certain uncertainties. So then we said, okay, why do I plan? Can I do learning on my own? So there is a planning and control, right? Of course, the learning part, I'll talk about it later. First of all, let's integrate planning and control. Well, how do I do it? Okay, when I have to navigate from this place to that place, that point is available, and then I draw a free path. Instead of that, I'll say, okay, my lidar is giving me the free space available. Let me do something such that, okay, this is a circle, for example. I fit a circle such that I know that my control is not going to go off the circle, and I keep going onto the center of the circle. So I'm just not doing the planning. Automatically the plan is there just by giving a waypoint as the center of the circle, and my control, which is a physical control, if it's a car-like vehicle, I know it can't do lateral. So guarantee is there that my control, whatever disturbances are there, it is going to stay within that circle. That's invariant set based pattern. And now with the sensor, we are going to keep fitting this particular circle every time. Now, if I want to go this way or that way to make a decision, I'm doing local planning right now. Local planning and control with the help of the circle. But now there's a global goal that I have to fix, which I don't know. If it's a known environment, okay, I can again do some kind of, a mathematical computation. Okay, this path is shortest, that path is shortest. But if it is not, then I have to learn. Yeah? So that's where, so if I run this particular video again, you will be able to associate. So there are green circles getting fit onto this. The red dots are from your lidar point clouds, and you keep going, fitting that circle and move on. Right? Okay. So then we said, okay, now let's try it out with the learning side of it. If I know the environment, I know these doors are open, sometimes doors are closed, so will I be able to move? So which circle, so these green dots are my center of the circles, which are possibilities available around me. And I pick that center, that particular circle, which is leading me towards the global goal. So there's going to be a kind of learning which is allowing me to say that, okay, there's a nice gradient available towards the global side of it, and that's how it learns. So that's what it's coming up now. So learning will keep making me sure that I'm going towards the goal. All right. So now the same integrated planning and control, we said, okay, I have seen the traffic conditions outside. Indian traffic control, autonomous driving is going to be very difficult, but somehow those bikers are able to do it. Indian bikers are very, very nice, and perhaps they are doing nothing but integrated planning and control. They are not doing point-wise this thing. They are fitting into the circles, free path, and going on. So then this data set that we brought it from some traffic scenario, spawned it on the robots, on this, and then my ego vehicle is moving from this. And then invariant set was in car-like, so invariant set was not circle, but rather a cone. So then we applied in different scenarios, blind turns, head-on collision. So it is, these ego vehicles are doing the maneuvers same as integrated planning and control. As soon as it sees the front car, it makes the maneuver change in a slide by just maneuvering it and making sure that they are not hitting each other. Okay, so talking about this learning and control, I've been doing research for about 10-12 years. Then I said, okay, some of us colleagues are sitting in Gulmohar cafeteria one day and said, that's it, that's okay. What we are doing is good, fine. Let's do something big. The next day, there was a call for proposal for establishing Technology Innovation Hub. And there gives me the opportunity to think about how do I apply my concepts in real scenarios? And how do I take these technologies to the commercialization level? Okay, so then we submitted, of course we got this in Internet of Things and so on, so I have to start thinking from the hierarchical side of it, how the communications, control and everything can be brought together. At the same time, we have been given, there was, of course this is driven by the ministry and said, okay, you have to do whatever you want, but you have to bring in scenarios, you have to bring in programs such that you are enabling the translational research. What is translational research? What is happening in our laboratory should go and see the light in the market. So then a lot of brainstorming went, because the entire flexibility and freedom was given to us to spend that 170 CR in 5 years and bringing an impact in developing those methods which can go to the market. All right. So a lot of things went. Then we put various different programs into different baskets, and then we said, okay, how we should filter out which is going into the market and so on, and how to fund it, right? So a lot of that discussions went around that. Along with that, why was that given to IIT Bombay? Then we started thinking about it. So then we said, okay, no, it's just these are just not the programs that we need to develop. Something similar what e-Yantra did. We should do some technical contributions too, and a focused technical contributions. So then my systems, kind of ideas, architecture level related ideas started spawning. We said we'll decide certain focus objectives and so on, applications, and we define what goes into it in terms of core technologies, and these core technologies can go into multiple applications similar to this robotics, right? So I developed this integrated planning and control for the indoor environment, but I'm putting it into the autonomous vehicle, maybe the Indian biker scenarios and so on. So so the lot of brainstorming goes into putting all these things together. So and these needs to be use case driven, need to be talked a lot with the stakeholders to bring in and bringing all of that together. So there comes, a little bit of my exploration went into leading such kind of deciding which goes into market and what doesn't go. Then I started thinking, okay, why don't I do it for myself now? Okay, TIH is established, its organization is done. Then I started venturing into the entrepreneurship side. Okay, so now comes my startup, robotics, and this develops nothing but what is developed in my lab is a spherical robot. Now this spherical robot needs to be use case driven. Somebody should take it. So the very first case that we had shown it to the security agencies, they said, okay, hey, we have done Uri attacks, we have done Taj Palace mein issue hua tha, right? So why don't we just throw this device inside a room and get the first feed, the visual feed that I can get in. At the same time, this should be throwable, this should be able to maneuver into the hidden spaces and so on. Fine, everything done. So then spherical robot was developed and it was appreciated well. But there comes a lot of different challenges there. I need to place camera. How do I place it? I had first placed it in the front side looking. But the demand is, okay, I need the back side view. Front side, though I will be able to see it to a certain extent. So I need the rear view as well. So there comes the camera which is mounting into ceiling, and it has a fisheye camera. I could have applied two cameras, connected two cameras, but there's a lot of load, payload, battery requirement, selection, processing that's needed, stitching needed. Yeah. So one has to start. When I started looking from the perspective that I have to go into the market, what is the simpler solution that is going to work for me? And that drove me saying that, okay, let's put that ceiling camera. All right. Okay. So of course, we are in the process of ruggedizing it. Right now it is teleoperated, and this is where one can look forward for. So this person is now remotely controlling it, and at the same time I get a fisheye based spherical circular visual this thing, which we have now made it a panoramic view in real time and so on. Real time makes a lot of difference, because now, since even though it's a remote control, it needs to be milliseconds delay only, because I'm giving control command, it should reflect back to the human that, okay, this is exactly what it is doing. Yeah. But what is more challenging here, what made this particular spherical robot interest to me, and I worked for about 10 years and so on. So seeing at different kind of mechanisms in the literature, this one is pendulum driven. What it is, there's a yoke and a pendulum. Yoke is making it to move in the forward direction. Instead of yoke moving, because it's a heavy blob there, yoke moving, the body moves, and that's how it moves. But when I have to steer, I make the mass, the pendulum, go into left or right direction, So there's a mass change and it moves in this way. There are other kinds of mechanisms available in the literature. For example, said, okay, spherical ball and just put a car, a differential drive car there. Okay, so how the car moves, but instead of car moving, actually body rotates. Then third is there are reaction wheel kind of thing, similar to in satellites. So these reaction wheels sit on the ball, inside internals of the ball. There are 3 in order to make such that you are able to do an omnidirectional seal. Then it's a shell transformation. Somebody has said, okay, I'm going to compress my shell itself and keep moving. Yeah. Then wind-driven methods, and now somebody has come up with hybrid kind of actuation, which is pendulum-driven as well as the wheel-driven. But what is more challenging here? It's the complete system. This system is highly nonlinear. Why is it nonlinear? Because inside this, especially what we froze is the yoke and the pendulum base, because I need to place my sensors there. If everything is moving inside, how do my wires will entangle? Where do I mount my sensors? If it's a car-driven, car-like kind of thing, sometimes it topples as well. Yeah, car itself is toppling, and car topples inside the ball. There's no way that I can bring it back. So such way, many such challenges, looking into different challenges, how I will be able to make it to market, we froze this yoke and pendulum based. But at the same time, when it is yoke and pendulum based, even if I mount an IMU inside, its dynamics with respect to this ball movement, we did a lot of mathematical part of it, couplings, and there's a lot of coupling which we are missing out. Non-linear modeling has been done, things are not working. Okay, there's some magic trick we applied, and some control is working now. That's where our USP is. But at the same time, now I have the platform available to mount my sensors or any other payload that is requested later on. So that's how the journey of my entrepreneurship started. I'm still doing it, but at the end of it, what I see here, what I have learned so far is adventure is the best way to learn. My adventure with TIH, now with entrepreneurship, and with my aiding role is an adventure. Engineering was the first adventure in itself. Alright, so what we have to look is explore like a little child. Yeah, every time today also I'm going to learn something and going out, taking it. That's all from my side. I'm open for questions, any?
Good morning, ma'am. I wanted to ask you, how did you come up with the idea to work on this spherical robot and among other ideas that exist in robotics?
Yeah. So there was a professor, senior professor, who was already working on a spherical bot. He is a modeling expert, and he was working on this traction wheels and then a single pendulum base. And he drove me in saying that, okay, hey Leena, you are doing an embedded control side of it. Why don't you look into it, what the problems are there? So what the problem was there is that both the designs had geared assembly. And as soon as it hits something, it will hit. No? So finally when we are doing exploration, any control, anything that we are looking into it, even we are driving to a forward direction, it doesn't pick up that speed that we are giving. So then the gears used to. I said, no, there is something we have to do first to satisfy this. So then we came up with the gearless design, and then I started saying, okay, this is a very challenging problem, and I got into it, kept on working. Sometimes it worked, sometimes it didn't work. If I'm not wrong, there are 3 PhDs, 5 master's theses on this itself. But a consistent effort had brought to this level, Then when we took it to the security agencies, they said, we started with football size. They said, no, we won't be able to hold this with 2 hands. Reduce the size. Then we have a patent on scalability. I can reduce size and so it's all driven by sometimes external requirements, sometimes our own requirements.
Good morning, ma'am. It's over. So, what are the specific application of this spherical robot which you designed? If you observe the images which we are getting that are not so clear, which video I watched a couple of minutes before. So, what are the specific application of this robot we are designing?
Yes, thank you for this question. So right now it is all going to be driven by the sensors that will be able to mount it. So right now it has only camera and IMU. IMU is helping me doing some kind of a control, low level control. But the camera is also driven by an application thought through, right? It's a surveillance application, reconnaissance application and so on. But at the same time, now when we are talking to various different industries, can you go under the table? Yes. So for example, there's a car in malls, and if I want to go down, right now this is a mirror that is being used for the inspection and so on. But if I have the images there, I will be able to do even video processing, image processing over it and saying that, okay, no, this is not a correct pattern, there's something wrong there. It's not human dependent. Doing metro rail inspection, where it can be rolled, there are certain limitations that we'll have to deal with. Always. So can it be rolled? Can I do it in the inspection within the AC vents? And then I will have to mount certain gas sensors. Right? So since I have the opportunity to put the sensors, there's some room there, I should be able to do that.
Thank you, ma'am.
Original use case was again driven by the security agents, I should say. Yes. Yeah.
Thank you, ma'am.
Now it's right now it's a passive device. It can be an active device anytime.
Good morning, ma'am. Can these type of spherical robots can be applied or implemented in defense era?
That's what we are looking at it. So this Dot Robotics is defense startup for me, and various different applications are being thought about. The very first one is definitely the surveillance one. But then there is going to be some fire finding the source in case of we don't have the enough information about the environment and so on. So there's just not the hardware that goes. A lot of it is a software side of it, which again I will have to solve things with SLAM also, with the help of SLAM or with the help of other AI tools. What is possible on robot is just the video transmission as of now. But there is a lot of possibilities at the controller side. That is, what kind of processing will I be able to do? Obstacle detection, human presence detection. Can it act as a spy camera? Audio can be there, so it can record and keep sending it out and so on. We'll give you this soon. Sure, we can provide you so that they can design it themselves. So, thank you. We are talking to Shivram, maybe next year. Thank you.
Good morning, ma'am. Here.
Yeah.
So glass is usually having less friction, right? Can it climb slopes usually?
It can climb a slope of 15 degrees and it can downhill also 15 degrees. But remember that this is just not a ball, but it's just only the rolling ball. It cannot hop. Right? Hopping mechanism is still not there. So the hybrid architectures that are there in the literature that talk about the hopping as well. So then perhaps it's possible. But the best part here is that the entire mechanical and electronics is within this shell. So somebody can kick it as well. So my job was to give them when to stop. So that is what again user-driven requirement. So for example, I'm here and I want to see what is coming at the blind entry. So I should not wait for, based on this speed it's rolling and whatnot, I will kick it and I'll ask it to stop. As soon as it hits and starts rolling, it is again not going to jump. So that's where within the limitations of it, what is possible is we have to explore.
And what about the muddy surfaces, ma'am?
Muddy surfaces, there is a challenge. Yes. Muddy surface, concrete, it is fine. You guessed it very right, because it is having a single contact with the floor, right? With the surface, and that's why the friction makes a difference. So in sand, no, it won't work. I might have to change its, form factor, the appearance of it, maybe ellipsoid and something like that, so that it can move on to this surface. So that there are more points touching the surface, more friction available for me to move. So there's a possibility of exploration there.
Good morning, ma'am. I saw your board depends on the outer shell. It should be clear for view, right?
Yes.
So because sometimes there can be dirt on the floor. So how did you solve this problem that the outer shell should be clear for view?
Should be clear for view. Yes, dusty surface is going to be an issue, but its surface is going to be scratch proof. Little bit of, not 100% transparent, but 90% transparent, such that the glare with the lights are stopped. So at least to that extent we are able to provide. So the application then limits to indoor applications right now. But of course on roads and other things we'll be able to do go, or in the metro rail inspection, or in case of the AC vents we'll be.
So have you thought of something like the outer shell like doesn't get affected with the dirt and stuff like on the surface? Have you implemented something like that so it stays
Dust-free
clear?
surfaces are possible, but not a 100% solution. So we are not exploring. Our focus is rather to look into what the demand is,
Okay.
right? And what is the best possible. We won't be able to satisfy everything.
Yeah.
Right? That is true with every product. Right? So when we go to the product level, we have to say, okay, we can give this, we can't give this at this moment. We'll work on it.
Okay.
But work on it needs money. Yeah.
Any final questions? I think 5 questions, all 5 have been about the spherical robot. Yeah, absolutely. No, I do have one question before winding up. It feels like now is the time, there's a lot of growth in robotics, even in India, in industry. Can you, as Dean, maybe you have a better vantage point to look at the landscape, right? So especially youngsters who are trying to start up and so on, any guidance?
Passion and perseverance. I think these are and curiosity, of course. Yes, perfect. I think this combination will lead you, because when you are in startup or going to the market, you are definitely going to fail. One needs to look into that, okay, how can I improvise, and finally looking into the cases, why and where did we fail. It's not going to be a very smooth journey. It's going to be a very, very jittery. You will see that, okay, maybe I've got a success, but no, there's going to be always something the customer will keep asking for it. So the journey is very difficult, challenging. Nevertheless, it's not impossible. And sometimes you may get immediate answer. Coming to the robotics side of it, what Shivram's question was, there's a lot of potential, because the concepts that we are learning in terms of robotics planning, I read one article today which is going to which has taken the robotics planning algorithm into solving the quantum control problem. So the next level is quantum inspired robotics. And quantum computing is nothing but using all our mapping concepts, SLAM concepts into going into that. So robotics is just not hardware, software, control, learning, many aspects coming together. You don't know which piece you are going to use it. And that's where the opportunity comes in, that market is going to look into all these aspects, interdisciplinary aspects that you learn in the robotics, what you are going to take it up. And that's why the robotics engineers are in the maximum demand, I should say. And hopefully that answers. And of course, there is a good push from the ministry, that is something coming to the dean's level to us, is Make in India, Indianization, and making sure that even those who have, those robotics engineers who have gone outside should come back and contribute to the India. That's it.
Thank you so much, Leena. Concluding with those words of encouragement for all our youngsters here, but also I think in a short span, right, compressing so much. When we were planning for this event, I was wondering, should I call a roboticist who's built robots? Should I call an administrator who knows a little bit about academia, industry? Should I call somebody who actually has experience in industry, doing a startup? So in one fell swoop, we've covered all three of those categories by calling Leena. So let's thank her very much. Leena, before you go, there's a small thank you from us.
It's my privilege to be here. Thank you
so much. All right, folks, the plan is to break for tea. 10 minutes. Okay, we'll be back in 10 minutes and then we have a panel discussion. 11:30 we'll start.
is back. वो पीछे वाले लोग, दिव्या, your row should come in front. Divya and Tamanna and Prem, I think, right? Please come in front. You guys are, I don't want last benchers, please. We have lots of space here and here. Please come down. And there also. Last row, please. Come in front, the young lady there. Okay, the ladies there also should come in front, that row. Please come in front. The last row here, yes, you. Please come here. Yeah, all of you, please come here. There's lots of space. You can all sit together. Okay, so let's get started. So, we are improvising a bit. But anyway, the question this panel is meant to encourage you to ask, right? The question that we want to answer, please listen, okay? Question we want to answer is, how do I become the kind of engineer that companies and research groups fight to hire rather than the one that AI replaces? How do I become desirable to research groups across the world and companies to hire me, right? And not to become redundant in the face of AI. That is what this panel is all about. And we have some extremely interesting panelists who will help us answer this question. And I'd like to invite on stage, first we have Sandeep Bhatt, Dr. Sandeep Bhatt. Who's heard of the company called Idea Forge? Idea Forge, the drone company, they are drones in defense essentially. They grew up outside my office actually in Crescent Building, where Ashish Bhatt and Ankit Mehta, who are the founders way back in 2007, were playing with drones outside my office in the startup incubator that we had there. And from there they've come an amazing way. So welcome, please have a seat. Dr. Sandeep Bhatt. And we have Narendra Patwardhan from Godrej Aerospace. He's one of ours. So he's from Department of IE and OR. I'll tell you a little bit more about them in a moment, right, once they've sat down. We have Harshad Kadilkar, who is an IIT Bombay graduate, and he's an aerospace engineer who's gone into finance. So he's making money fly instead of planes fly. Okay. And then we have Shivram, our very own Shivram Kalyanakrishnan. Let him join us here on the panel. I'm going to be on the side and I'll do what I like doing best, which is inspiring and chavi lagaing our panelists. Okay. So that's what my plan is. Sandeep, I'll tell you a little bit about him, right? He's a bachelor's from VJTI in computer science and his PhD is from Ohio State University in the US. He's been very busy with publications and patents and all that in the past, but now he's doing some real work. And that's as senior director with Idea Forge, one of India's leading UAV companies. And he leads the software R&D work there for mission critical unmanned aerial platforms. You know what they are, right? Planes that do interesting stuff. And his work spans things like embedded flight controller firmware, UAV mission planning. If someone would please close those doors, it would be very useful because they do a great job of bringing the sound from outside inside. So he drives the company's AI and ML initiatives, right, in computer vision and data analytics. So he's got 20 plus years experience, right, which is what explains why he's a little mature across embedded systems, distributed systems and whatnot. So that's Dr. Sandeep Bhatt. Then Narendra Patwardhan here is an IIT Bombay alumnus from the IE and OR batch, which is at IIT Bombay, and he's got 25 years of experience across L&T, Tata Group, Tata Aerospace, and now Godrej and Boyce. So wide experience, and he's an associate vice president at Godrej Aerospace, and he leads the business excellence, sustainability, IT initiatives and all that. And he's deeply involved in driving digital transformation through projects in IoT, AI, ML, robotics, automation, all these kind of things. So Harshad Khadilkar is a BTech in Aero from IIT Bombay and a PhD from MIT, and now he's with Franklin Templeton, right? But his passion is aerospace. So his hobby, well, the thing that he does at the moment, as I said, he makes money fly, and he's been working with Professor Shivram to see how money might be made to fly more effectively. But now I'm hoping that he'll help us with drones and how to make robots also fly. And Shivram, you know, right, he's one of our own, and he's the PI of e-Yantra, and he's the one who's going to lead the charge into automation and AI for e-Yantra. And he's already done a fantastic job. The turnout here is amazing. And we have these girls who are doing the women in robotics workshop, and we have a large turnout here. Lots of young lady engineers also, which he's made a special initiative to get more women into robotics. It's not a coincidence that he has a daughter also, so he's got high ambitions for her, and he wants to start with you guys. So great, welcome on board. Big hand for them. Right. So how do we turn ourselves into a very valuable resource? Hey guys, the door downstairs needs to be closed. Okay, so that's what happens at e-Yantra. You express an idea and someone goes and does the work. It doesn't matter who does it, but somebody goes and does it. That's something very special, by the way. I've noticed in e-Yantra that we think like an organism, right? If something needs to be done, somebody, whoever it is, myself or a junior staff member, colleague, whatever, they just go and do the work. They don't think about, is it my job or not? So I think that's something that we need to learn from. So 5 years from today, AI can probably write better code than most of us. Do you agree? 5 years from today, AI will write better code than all of us. So why would anybody hire you? Why should anybody hire you? Okay, answers. Could anybody volunteer? Why anybody should hire you tomorrow? Creativity. Okay, creativity. What else? Why would anybody want to hire you? Because you look nice, you wear nice clothes. Why? AI can write better code than you do. Problem solving.
This challenge that So now imagine that if this is your own code that you wrote, which 6 months or 1 year later you are not able to understand and figure out whether it was right or wrong, how are you expected to know this, what an AI tool is doing for you, right? So the ability to understand what the AI is doing, analyze it critically, figure out is it solving the problem that you had asked it to solve. which involves first of all asking to solve the right problem. That is the most fundamental part of it, right? Wrong problem solving is not going to help them. So I think that is broadly, I would say, what will make engineers relevant in the years to come. So just to answer your question, sir. And coming back to the actual question that was posed. So 5 years ago, I think largely, and both from the perspective of hiring, which is what we used to do as a process while hiring, and also what engineers do after joining, right? And this is a very relevant audience of e-Yantra because robotics inherently is a multidisciplinary field, right? Unlike many other domains which are more specialized and niche. So, to a large extent, what were the core skills we desired 5 years back versus today have remained unchanged in some ways, right? First principles thinking, ability to solve problems which are multidisciplinary in nature, which span different domains. Now, the expectation of what kind of problems that campus joiners or relative newcomers will solve would mostly be in the execution phase. So somebody is mentoring or guiding young engineers, they are learning about the domain and then learning to apply those knowledge and skills in real world projects. Right? So that's what used to happen during the typical onboarding process. What AI has done is it has democratized that knowledge to a very great degree, right? And therefore, the people who are joining the workforce are extremely well prepared. So, like all of you, I was seeing some of your projects, and some of the projects that we have done in internships are the problems that we are solving in industry today.
But these are exceptions.
True, but I think the student community is much more informed, and certainly I was a student decades back, so at that time there were hardly any such tools. But students are much more informed. So the ability to consume AI, apply critical thinking, and accelerate the outcomes is something that is a talent or a skill that is looked for. And certainly mundane day-to-day activities of translating ideas into code or prototypes, which is what we used to spend a lot of time on 5 years ago, has been accelerated. So the impact and the outcomes can be amplified much more. So I feel that both from organization perspective and also from the students' perspective, I think that has become more fulfilling because you are not constrained by individual boundaries of knowledge limitations or domain limitations. You truly have an opportunity to become multidisciplinary and contribute across domain boundaries.
Okay, so you got one aspect there. I'd like to ask Godrej Aerospace now, right, Narendra. What work has disappeared because of AI in your organization? And what new work has appeared?
So I would say fundamentally nothing has disappeared because the products that we have been making, we are continuing to make those products, and as Sandeep was mentioning, what first principles that are not going to change. So I would not give any credit to AI as of now, at least, that it can make things disappear. However, one thing that this great power of AI is bringing in is the speed at which we used to do the same work. I am saying AI is not doing any different work as of today at least. But the increase in speed is phenomenal. And that is the power of AI which we see, because of which I would say the requirement of resources in certain cases, particularly as we all know that AI is currently the way it is positioned today, and the Gen AI particularly, it's more about text, and so where a lot of text is present in the system, those kind of functions are actually getting benefited, and in terms of resources required today, obviously there will be a drop in the requirement in future. But when you look at the engineering, because I think the context here is all about the work, the robotics, and these guys are going to do. It's not about processing any HR records or maybe legal, all these things, or banking, finance sector and all that. That is because I am coming from manufacturing, so my the whole attention goes always towards manufacturing. But these are the sectors, the other sectors like banking and all, where AI is actually rapidly making work disappear, as you would say. When it comes to manufacturing, AI is actually going to increase the speed, and the ideas are still going to come from you guys, we guys, and we are going to use AI like we have used as engineers always. All engineers all the time actually have been putting their the natural intelligence first into that, and then going to use AI, and that is what we aim to do. Obviously, as the speed increases, we should convert it into an opportunity to grow faster, rather than looking at it as something that this work is no more required, and so I don't need a resource here and there, and so let me save some cost. Instead of that, we shift the paradigm should shift towards throughput increase using AI, and so nothing disappears in that sense. In fact, you grow faster using AI. That's how we look at AI as of now.
Okay, interesting. So what Sandeep was saying, he was referring to AI has democratized knowledge. So the thrust is now on hiring for people who can solve problems, but he was actually meaning articulating problems. And you are saying that in manufacturing, it's affected the speed of work. That means you can manufacture more stuff at a faster rate because you have this AI booster, if you like. I'd like to ask Harshad how his industry has been affected by AI, because a lot of young engineers aspire to get into your industry, especially IIT engineers, right? So tell us about it.
It's definitely been affected, and what I feel is that AI has enabled you to not enter at the first level of employment, which used to be that of a developer. So it used to be that in your undergraduate curriculum you learn Java and Python and other languages, and once you join your first job, you would be told, write this function to extract this data, these columns from a particular table, etc. And you would have a couple of years before you had to reach the level where you could give work to other people. At this point now, you definitely still need that skill, because AI can always make mistakes and you have to be able to audit what it has written. But while you're doing your undergraduate itself, you need to reach the level of a team lead, which used to have an additional 2 years of further point.
So you're expecting more from them?
Yes. And once you join the job, your first job is as a team lead, because you are leading a team of AI agents now. And you need to be able to assign them work and audit what they're doing. That does not mean that you don't need to know how they do their work, because that's not how a good team lead works. They have to know what their team is doing and whether it's right or wrong. But you also need a higher level of knowledge about what we are trying to build and what work needs of them.
So essentially you're saying that you don't hire pittus anymore, the Godagiri types who do functions and coding and all that.
Yes.
You are hiring real consultants.
Yes.
But we don't train them to do that in engineering college. So how do you hire?
That's the challenge now, that we need people with high levels of natural intelligence who can use artificial intelligence.
Okay, we'll come back to that. We need people with high levels of natural intelligence, right? Who can use artificial intelligence. That's a very quotable quote actually, right? Shivram, so people say that AI will replace engineers. Do you believe that?
I think that calls into question the definition of an engineer. So really I think it's already come out that somebody whose job is to live in a society, understand it, and solve problems for it. An important integral aspect of that is understanding its problems to articulate, formulate, right? And then, of course, use tools and techniques to solve it. I think there's a big need for us to keep filling so many voids which are there, right? And the part of deciding these problems to solve, designing solutions for them, right? And then using AI as a tool. I think there's still going to be the need for an engineer as long as society has room for improvement. The role of the engineer, I think, profile is changing a little bit because they're, as Harshad has said, not writing the Java code anymore, right? They're using AI to write the Java code. But the overall bigger problem of, I don't know, like putting food on the table, right? Doing agriculture, doing manufacturing, all of that, that's an engineer's responsibility. That's going to stay as long as you're going to need food and shelter and so on.
I am confused now because in engineering we tell them that you read this textbook and you pass this exam. We've never talked about society and all these kind of things. Aren't you expecting a bit much from them?
Bluntly put, I think that's what we expect from them.
Okay.
Go beyond your textbooks, go beyond your syllabus that somebody is giving to you, right? Build with your hands, think independently, right? Forget about instruction coming from somewhere else, right? Be independent agents who are using this new thing called AI to reflect, solve the problems that are solving independently.
So anyway, we'll hopefully come to the end of this conclusion by the end of this panel thing. But that's not what we are training engineers to do, and that's where we need to change ourselves. So what he's talking about is that we expect you to solve societal problems. I don't think anybody has been told that. But to solve societal problems, you have to have empathy. We don't give them empathy. Empathy means that you believe that you own the problem, that society somehow will not magically change, but that it's your job to actually make things change. But this is not what they are told from school onwards. They are just told to pass exams and you'll get a job. Right? So we'll have to come up with some answer with which we can change that mindset. So let's get to brass tacks now. Okay, these guys want a job in a couple of years' time. Okay, I'll start with you. Sandeep, you receive 500 resumes, right, every day. What makes you stop scrolling? How do you recruit? It's not your job, maybe it's HR or whatever, but they are primed by you, right? So on what basis do they recruit?
Yeah, so I think the hiring process has been transformed significantly, and one is at the screening level and one is at the interviewing level. So just I'm sure like professors and teachers today are finding it difficult to set take-home exams because everything can be solved using AI. The same thing applies for interviews, right? So, in fact, we've changed our interview process that for every role we have a take-home exam, and we encourage people to use AI. So the challenges of the hiring managers: what are the skills that you need, right? And how can you design a problem? Because the engineer is going to have AI tools at their disposal. So why do you put artificial constraints on them and make it difficult for you to judge whether or not they have used AI? So what we ask for is a report which they generated using the help of AI tools. The hiring manager reads that report. I never read that report because all AI tools will generate the same answer, whether it is Claude, Gemini. What I read and what we ask them to submit is what are the set of prompts and the follow-up queries and the conversations that you had with the AI agent to arrive at that report. What were the system assumptions that you had? Always the questions will be ambiguous. Because this is what information ambiguity will, too much of information will cause ambiguity, right? So what were the assumptions that you made? What were the constraints that you imposed when you came across? So even in the resumes that we are screening, we don't look for generic things, okay, I did XYZ project. What was the specific challenge? Did you solve a specific challenge? Okay, this system, I solved a real-time constraint, so I'm talking about the embedded and robotics domain. So I was able to hold it from on an embedded platform and improve from 5 FPS to 12 FPS. Right? So it does not need to be perfect. I got a perfect solution which achieved 99% accuracy. We are not fielding solutions today which are achieving 99%. So I think to a large extent, the kinds of problems that you solve, the kinds of constraints under which you work, if you are able to articulate those well, those are much more relatable than generic things of saying, I did so many different things. Like but then depth and criticality of thinking, if it can reflect in the project. So it may be a small contribution. You did not say that I built the whole robot, but there was a fundamental problem that the robot when it was processing sensor data, it was only able to process at 5 hertz. And I used my engineering skills, knowledge, optimization, etc. to make it run at 12 Hz. That's a very significant, and probably that is something today that AI is not very good at. The intersection of algorithms, hardware, and optimization is something that requires a little bit of hands-on work. So I think those are some of the things that we look for in terms of specific things that people.
So I don't envy your HR manager, because this can't be done by AI. It has to be done through reading through all these things to try and pick up these little things, right? But note what he's saying, that they engage you in a discussion in which they can just take one assumption that you've done. That's what we also do in the interviews, right? You've done something, now explain to us why you've done that, the basis on which you've done that. So unless you actually own the project and you've done the work yourself, you cannot answer these kind of questions. And this is why our kids get hired very fast, because they've actually done a project, and the scrutiny system of the entire competition has been based on objective things that they've done with actual hardware and design and all these kind of things, right? So this is software, right? In the manufacturing side, how do you hire? What do you look for? Because you have a number of mechanical engineers and all that here also.
Yeah, so there again, as I mentioned, since the manufacturing, the speed of course will get changed using these technologies, and so what we look for obviously is the skills, the new skills that are there in the market. So when we would hire, obviously we look for people who possess those new skills, because those are things which our competitors would be using, and so we need to also use them, otherwise we can fall behind in the market. So, but apart from that, as far as the, again coming back to, let's say, mechanical or whichever is the fundamentals of any engineering side. Okay, now one thing which we just had one question before that is about whether AI will replace engineers, kind of thing. And on the other hand, we are actually recruiting AI engineers. Okay, so the engineers, the tag is still remaining, and that will always remain, because engineers are actually for ingenuity. Even then AI also will be finally requiring engineering attitude to be applied to it, so that you can fruitfully use it. I am talking about doing peaceful things, even or for defense of, even if it is for some destruction. I mean the product is for destruction, but it is for defense. But normally, otherwise in the industry, we are talking about things which are going to help society, as you were mentioning. And so the attitude or the aptitude that we look for in freshers or any level when we hire, it is one thing that is going to get added to that is your skills, modern skills. Whether AI is one part of that, not necessarily AI. AI needs a lot of other things behind it, like the data analyst, and the IoT is one big thing, because when we started, as the last question when we were talking about, the first obstacle we faced, and even today, let me tell you that still remains a big obstacle before we even start to think of using AI fruitfully, is to have that data in place, the right data in place, and updated data in place all the time. Otherwise, AI is going to mislead all the time, which is not going to help at all. And so these skills again come on those sides which are more on the hardware side, I would say, or the not okay. The AI is going to do the programming, but which data you want to collect from where is something you need to figure out first. What is more critical for the business today is not what AI is going to figure out of itself, until and unless you create a good enough data, and then AI can start helping you. And so today we are at this stage, at least in the industry where I have seen, is that the accumulation of data required, sufficient data required, and the speed at which it is required, and the updates that are required to that is something which comes from those ground level systems like again IoT, SCADA, and a lot of PLCs and automation systems that we use. And we look for those type of skills before we look for processing of them. Probably, and you know that everybody knows that AI is not going to be cheap. It's very costly, and so that part is going to play a role. And so people are going, and that's where when this private AI and all things we are talking about now. So we are very much conscious about the cost part of it. Every company sooner or later has to think about it, particularly the manufacturing. You have to have you cannot disturb your P&L for that, even though you can look at it as an investment. But then today calculating ROI is the biggest question in front of us as to when we have to justify any investment, even in AI, let's say, and then there are security issues. And so I think we will be, it's probably maybe 1 year down the line, I may be talking something else about AI because the way it's moving is.
So Naren, if you are recruiting today, you said you want new skills. But sorry to interrupt you, but these guys have a very specific question in their mind. What will it take for you to hire me?
Yeah, so the use cases as I mentioned, so one is that is at the base level, and then since you are coming from the robotics background, so this physical AI is the thing which interests us more rather than the Gen AI and the other processing type of thing, or helping you to write an AC. That's not what really helps us in the industry. Because as I mentioned in the beginning, the products that we are making. Of course, the products are changing from the customer side itself, and so the changes will happen. But I'm talking about the things where electronics, if you leave aside electronics, there is a lot of other stuff which is non-electronics. And there we need these kind of fundamental things to be, we look for that type of knowledge, which is purely the robotics, the physical, and then the use of AI within that is in that domain.
Thank you. So what he's saying is basically he's looking for something different. He's looking for new skills. He's looking for AI used in a physical space, because these guys are working with embedded systems and missile systems and all that, which they build under license and all that kind of stuff. So I hear it's in public domain. Okay. And a lot of manufacturing is outsourced to them. So they want people who can think about these kind of systems. Physical AI means that your system is actually a missile guidance system. I don't know how much flexibility you have in actually building these things, but they would like people who can spot things which are not quite in the right place and all that kind of stuff, right?
I am referring to manufacturing.
Manufacturing issues. Okay, fine. Thank you. So, thanks for that. Harshad, what is it about an intern that makes you hire them right away? Right? Like say, if you are recruiting today and you see something like, I want to hire this guy. What are you typically seeing in that?
So three things. One is obviously mastery of the basics that is expected from everybody. But the two new things that have come in because of AI are, one, the recognition that at the end of the day you are building something that a human will use. Therefore you need to anticipate what they actually need and whether what you have built works for them or not. Right? Even something as simple as a banking chatbot doesn't really work if it gives you templatized answers and it just says, I'm sorry for your inconvenience, I tried to fix this. Just forget all that, give me the solution, and that's what you always think. So that's one. And the other is to think about edge cases, which is as a human you can be uniquely pessimistic. You need to figure out where things might break. Like an example we saw a few months ago in the e-Yantra competition is that people had calibrated the light sensors outside in the foyer, and when they tested it here during the actual competition, they didn't work. And those are the things that are uniquely human that you can try and predict, which an AI will not do. It will build you 90% of the system that works in 90% of the cases. The remaining 10% are something that you always have to understand.
Okay. What would you look for? There is this thing about AI is getting commoditized also, and there is this thing about it's becoming very expensive. So what is your view? It might be cheaper to hire a human being than to get a good cloud license or something like that?
I'm not sure about that. Maybe when prices will come down or we find some other equilibrium where the economic aspect doesn't rise so much. But I've been actually waiting to say something. Credit together, I think the people have been coming from Montreal then. So I don't hire people for jobs because I don't belong in the industry, but the similar thing that happened in academia is we have students applying to e-Yantra for admissions in the department and so on. So I want to actually directly tell all the students here something. There's of course one aspect of how you do your work and so on, but the other is communicating. Okay, so communication comes in the form of actually writing your statement of purpose or of preparing a report with somebody who's going to hire you, who's going to read and so on. And you know it as well as I do, literally everybody is using LLMs for doing this right now, right? And sitting on the other side, right? We are human beings and it takes very little to look at something and say that this has come from an LLM. And as soon as we see the signal, right, it sort of puts us off, right? We would like to see the other side of human being expressing themselves with all their rough edges, right? With, I don't know, unique kind of mistakes, with other idiosyncrasies. That's much more colorful and interesting to read, right? Rather than everybody saying, I have developed a deep passion for robotics, right? When I was born, I saw somebody flying an aeroplane. So there are all of these telltale signs which we would like to, I don't know, not read, right? So please, I would say, e-Yantra interns who are here are going to prepare a report and so on that you this week. Be original, be yourself, right? Let go of the sense that LLMs will give polish and professionalism to what you're doing. Maybe they do, but what you lose in the bargain is you, right? Reflecting through the document that is provided. Students will start doing this for email, right? Have somebody who wants to basically say, please postpone tomorrow's meeting, have ChatGPT do it for them, and just reads like something else, okay? So, particularly the aspect of communication, right? Try and express yourself as directly as possible. Try and not have LLMs do it. It will make it better. I mean, the first thing was talking about looking for things like, have you taken the trouble of identifying the problem and increasing the frame rate of your processing, right? If you've done that, say it, right? And that rings a lot more loudly compared to, I don't know, having a very standard boilerplate thing that comes out through the, that's one thing I'm going to.
No, so I wanted to ask you the same thing I was asking them. When you hire someone to join your PhD program, what are you looking for? I think that it matters to them.
Okay, so for a PhD program, we would like somebody who is clear on their fundamentals, right, who knows the basic building blocks well, who's able to apply it. Okay, so for example, I work on this topic called reinforcement learning. I'm not looking for somebody who already knows reinforcement learning. Okay, I'm looking for somebody who is able to reason about basic mathematical concepts, logic, right? How to sort of put things together in a structured way. Right? Somebody who is able to think on their feet, doing basic stuff, will be able to pick up whether it's reinforcement learning or panels or robotics or whatever it is. Right? So more than already doing what you're getting to, if you are somebody who has basic skills, okay, which can be used then for any purpose, that is a better hire that you're looking for.
You know, these guys are struggling so hard to become toppers, and you're not giving them any importance at all. You're talking about all sorts of vague things like critical thinking and, you know, who knows basic maths and basic this. So answer that. Why are you not being a topper?
I don't know. Outcome of the fact that we live in a country with more than 100 crore people, right? Scaling. Okay, that is the thing I think that comes in between. Ideally, right, I would like to teach a class of 10 students, make eye contact with them, have like a much more direct person-to-person relationship. But we cannot have an antibody. Why is this classroom so big? This classroom seats 320 people because we have more and more pressure to take more students. If I'm teaching a class of 320, right, I cannot really know everybody's name, right, during the course of the semester and be able to evaluate people by reading each individual report. So I think because we have to scale, we have to have these common exams, we have to have these much more aggregate ways of filtering out people, which of course is not ideal. So to some extent, you have to get past those filters also, right? That's a sad fact, I think, of the simple fact that we live in a big country. But I think in a smaller setting where there is scope for you being evaluated more qualitatively on a person-to-person basis, we things that stand out are precisely, maybe, I don't know, antithetical to the ones that really pass those big filters. It's not about getting top rank, it's able to, it's about being able to hold a conversation, explain yourself clearly, talk about things, right, at a sort of basic level. So, yeah, I think there's really two sides to this. We should not, I think, act like we live in an ideal environment where there is this scaling phenomenon that doesn't happen. It does.
So, you know, it's quite interesting. Yesterday we had a workshop with the faculty here, and I created a variety of Menti polls, right? So ask them, what are the things that get in the way of the students and yourselves doing interesting and the creative things? The main answer there was the curriculum. Curriculum prevents us from doing anything interesting. Remember? I wonder if you're there for that part, right? Curriculum is what prevents us from doing anything interesting. And many people who take part in the e-Yantra competitions and initiatives say that this has taught me more than, this 6 months has taught me more than my 4 years of engineering college. So we've discovered something that is important, which is being missed out. And that's why we like to believe that we sit like a kind of a kavach, a protective layer on your existing engineering education, and we've not tried to get into mainstream because this gives us the freedom of being outside and doing whatever we want, being relevant, up to date, futuristic, right? But now I see the need for us getting into mainstream also, which we are trying to do with the engineering exploration program. If we can mainstream the participation of you guys in these programs and get academic credit for it, I think that will be a good place to go to.
Actually, not a bad time to ask an audience for, given there are so many questions, right? So if you were not doing it on the side, but you were doing it as a course in your college and you get credits for it, would you prefer the former or the latter? Should it be a part of your curriculum, yes or no? Yes. Everybody's saying yes, everybody's saying no. Don't you think you're putting songs into it because it's not a part of your curriculum? Okay.
So I'd like to come back to this. We don't have much time, so I'll just do one round and I'd like to open it up for questions. So, Sandeep, would you rather hire a brilliant engineer with average AI skills or an AI wizard who doesn't really understand engineering? Would you hire a brilliant engineer with average AI skills or someone who's an AI wizard with not that solid fundas, if you like?
Yeah, maybe I should ask Claude what the expected answer is. So I think there are certain skills, I think across the discussion we've seen, that are fundamental. So communication, someone mentioned, is very important. Ethics, empathy, perseverance. I think these are the things that will make you a good engineer. Right? And communication, and again critical thinking and reasoning. So it's not, I don't think it's exclusive. I think the ingredients or raw material that goes into making a good engineer also translates into making you a good, AI practitioner or being able to leverage AI. And the reality is that you will have to do both, right? And I think the folks who are here are actually having that aptitude and interest, and therefore you folks are here. So I think it's not an either or, it has to be an and. I think more importantly, the collaborative aspects of work going forward, I think especially in multidisciplinary fields like robotics, understanding the perspective of, okay, what does my, a design choice that I make have an implication in the sun. Just give a very domain-specific example from UAVs, which is where we work. I have a most sophisticated algorithm, but it requires an NVIDIA tester to run it on. Now, what does it mean in terms of the thermal management? How much weight is it added to the UAV? So, unless you talk to your colleagues from mechanical, from electrical, a good software engineer will not be able to design a very practical system which will work in a visual factory. So, I think those are the kinds of broader engineering skills, and that's why do we have engineering 101s, right? And how do we make the most out of them? So I think today, beyond those engineering 101s where you memorize material and just write it in an exam, I think fundamentally how you learn to apply it, and now develop systems thinking. So I think today's systems thinking and systems integration will be the most critical skill because low-level code generation will largely be solved by in the next few years. So I think those are the things where leveraging AI to understand what are the aspects of peripheral things that you need to consider and then applying deep thinking in your way is what will make you an idea.
So that's very interesting. I was going to say it, but you articulated it well. He is saying that a systems engineer is needed who can look at all aspects of a system. And that means to be a systems engineer, you have to know a little bit about all different aspects, not only your own software, you have to know a little bit of civil, mechanical, you need to know engineering overall, basically because you are a mistri who has to develop something which the user wants. So perhaps, Naren, you might have a view on this, because see, the manufacturing sector in India is pretty weak. And we are saying China +1 and all that, right? And what's happening is that all our civil engineers, mechanical engineers, electrical, all are going towards software. And in the past few decades, they've been soaked up by either software or finance, right? What is your view on this? How to attract these guys and motivate them and tell them that, look, mechanical engineering is more important now. Right? Like they say, plumbers will have jobs, electricians will have jobs. Mechanical engineers will also have jobs now as a result of this the China +1 opportunity that we have.
Yeah, so China +1 is actually has arrived because of COVID first, and then now people are continuing with that. But more than that, the kind of now coming back to the education, you are referring to that, and the curriculum and that part of it. So when we are actually looking at the engineers from deployment point of view in the field or in manufacturing as the context is, so the mechanical engineering or any conventional engineering is not that it is back because the other things are getting taken over by AI, but actually because how they went to these fields first is one, of course, opportunities which came in plenty, but as everybody knows that still on the product side, at least India, if you look at it, we have been even there we have been weak, developing any products in the IT side also. So whereas in mechanical we have been good conventionally, maybe for 100 years we have been making good products which are getting consumed and also exported, getting consumed domestically as well as exported. And so in manufacturing we have been doing good. So the mechanical engineering never had that kind of lack of opportunity here. They went there because the things were more attractive, but that has helped mechanical engineering field itself because those things got automated through the CADs and the 3D CADs and all that. And all that is now taken over by AI, which is now doing CAD itself. And so there is, really speaking, if you go back to let's say 10 years back, 15 years, 20 years back, fundamentally nothing has changed. The products were being designed at that time on the drawing board. After that it went to CAD, and now AI is doing that CAD. And so the technology is being deployed to do the same thing again and again actually. And the products are changing, by the way, as per the needs of the consumer and customer. And so the requirements for mechanical engineers still remain. And as I mentioned earlier also, the ingenuity, the market and the business and the market that is going to call for new products and new ideas and new, kind of needs that the customers are going to come up with all the time. And that's where, whether it is mechanical, whether it is electrical or any other field it belongs to, you belong to, that is going to remain needed. And so there is nothing that you need to really worry about even today. And again, look at it once again like this is an opportunity that you have a technology now which helps you to improve your speed, but your thinking, your creativity and your aptitude still matters when it comes to manufacturing.
Thank you. I'm prompted to ask you a very mischievous question. You are very succinct in your response. So I'd like to ask you, do you feel that you should have stuck to aerospace And if you did, what kind of stuff do you think you'd like to have done or do now? Harshad?
I still do like aerospace, and I find that the concept generalize very nicely across industries. So in my career I've worked in transportation, logistics, energy, and now finance. And in every field I've always had the passion of applying an abstract concept that I've learned in engineering to an actual system, whether it's aerospace or finance. And even in finance, my passion is not just in finding the little niches that make me more and more money. The original idea of finance was to allocate capital to industry, and that's what I like doing right now at Franklin. And maybe, help people protect their retirement savings. Those are two things for which finance was intended. And so as long as I'm working on something that actually touches, like I said, a person or a physical object, I'm happy.
Great. So I can see from that an engineering training is actually something which helps you in whatever you do in life, right? In the interest of time, I'm just going to sort of end our thing with one statement for each of the things. I'd like to ask each of these panelists, 5 years from now, Sandeep, 5 years from now, the engineers who succeed will be the ones who ... Your take on it.
Think end to end.
Systems engineering, think end to end, right? Think end to end. Naren, you?
Yeah, I would still stick to that. Don't lose your engineering aptitude in all this ocean of this technologies getting available to you. Use them for your benefit rather than getting lost in them, like the social media took over a lot of killed a lot of our time. So same way, like examples we were talking about ChatGPT and all. So use it fruitfully. Don't keep aside your engineering. That is will 5 years or 50 years. It's going to give you the fruits.
Okay, interesting. Harshad, you, 5 years from now, the engineers who succeed will be the ones who
use engineering as a springboard rather than a protective cocoon within which outside which they do not want to go.
Who use engineering as a springboard. Shivram?
Think Indian, make Indian.
Think Indian, make Indian. Big man. So I'd like to just kind of sum up before I just open the things. I think the questions are very important that we should get from the audience because they know you now. But I can see a lot of things which are more important than the kind of education that you guys are subject to. Working as a team, critical thinking, thinking systemically of the entire problem. Even the kind of employees that people want to hire are not the pittus, do this, do this, do this. They want to hire people who have the initiative of articulating problems. Now what do I mean by that? Right? I want to go there. The person should be able to say, sir, if you want to go there, here's an alternate route, or you can go this way, or you can do that. I want them to take my problem as their own and solve it, which is what we've been doing in e-Yantra a lot. And that will create a totally different kind of individual who makes a very good researcher and makes a very good entrepreneur also, right? So that's very important. So throughout the 2 days here, we've seen some remarkable robots, drones, AI, but today this discussion reminds us that intelligence is now becoming abundant because of AI, but something called judgment is still rare. And judgment only comes through experience, and experience comes only through contacting reality, through solving problems and all that, right? So judgment is something that we need to develop, and we can only develop that by exposing ourselves to lots of challenges of this kind, engineering and various things, and build that kind of judgment. Coding is taken for granted, but you should be able to figure out whether the computer has generated the right code or not. Has it hallucinated or not? Can you triangulate somehow by your reasoning whether the code that the computer has given you is the right code or not? So that the way, like getting an intern to do some work, the intern might not have done the right work, right? So you need some work as a manager also to figure out that the intern has done the right work. So that's a sensibility that you have to develop. Something very important that they've been saying without saying it is curiosity is very important, right? You should be curious about disciplines other than your own, right? Character is very important. They've kind of been implied, they've been implying it, but Shivram has kind of thrown darts at this thing, but that's what he means. Character, in the last statement that he says, India is your responsibility, you should have the character to accept it and do something about it. Engineers are problem solvers, not just any old problem like creating a new TikTok or something. Can you actually make some impact on society? So we believe, at least I believe, that the next engineer will not be the one who competes with AI. It will be the engineer who knows how to use AI to solve problems that really matter. And that's the kind of engineer I hope that e-Yantra is going to create. And something that we need to kindle more amongst our youngsters, which we have not articulated yet, is a feeling of empathy. Right? All these things happen only if you feel empathy, if you feel that the country belongs to you, the problem belongs to you, that the situation is as it is because I could perhaps be doing something to make it better. I think that's more important, and that's what e-Yantra has been trying to do on its own, but that's the spirit which exists in large doses at IIT Bombay, where many of us can be anywhere in the world, but we choose to be here because it makes a difference. And I think that's a great place to pause here and to take your questions. You have an amazing panel here, so over to you guys. But big hand to the panelists. Questions? We need a mic going around. Dazzled by science. Okay. Any of the faculty? आपकी खिंचाई हो रही है बहुत आजकल. Yeah. Will you announce yourself and give your question? You have a mic there, by the way, Shivram. Next to you. You're holding a mic.
Good afternoon. My name is Tausi. I am from Australia. As Professor Arya started with a question to whether AI will take away jobs. If we look at AI elements, at the heart they are a probabilistic model, right? So it's inevitable that they will hallucinate, right? So my question is the confidence that whatever output AI has given, how do we what confidence do we have in that output, whatever it has given, and don't we always need human verifiers? And that should be a reason or the reasoning that AI will not for sure take away jobs, human jobs. Second, as Mr. Narendra stated from the defense, last time, a few months back, we saw that there was this Anthropic was in news because there was a news that DOD is using Claude as in their missile system, right? So again, how does defense have confidence in the decisions that AI makes since they can hallucinate? Thank you so much.
So I think the question here is that should the human always be in the loop is one, and second is that how can I believe AI?
I would like to take the first attempt.
Yeah, just hold it close to you, like a rock star.
So the usefulness of AI is not in ensuring that it has 0% hallucination. Right? Even humans are probabilistic agents. So to be useful, AI only has to write better quality code than a human does, which it already does. So it's not that you expect AI to be used only when it's 100% correct, but you do need to have verification whether it's human or AI based. I would say a mixture of both humans and AI need to be working together. And it is going to take away some jobs because those jobs profiles are now morphing. There is no such thing as a simple engineer or a simple data scientist. Like I said, you start as a team lead. And that's what you have to start thinking about now, that I I do not just need to learn this programming language or this mechanical robotics concept. I need to know what to do in my first job.
So why don't you elaborate what you mean by team lead? Because you've been saying that a lot, right? I want a team lead. Now what is a team lead?
Yeah. So for people being in the industry for a few years, you will learn to start to think about a project level description of what you're trying to achieve overall. And then you assign individual tasks to people traditionally, and now those individual tasks, some of them go to AI agents. So assigning tasks, verifying the accuracy of those tasks when they have been delivered, and making sure that what projects you are working on are delivering what you intended. Those are the tasks you now have to start thinking about at a higher level. That's what I meant by
So I want to ask on the behalf of faculty, how do we train students to be that? Shivram perhaps, yeah. How do we train students to be team leads?
I think to some extent the activities we are providing here, right, where you actually learn all things by experience, right, you work in groups, right, you can't build something in an open-ended way, right, you have to communicate with others, you have to prioritize, you have to do all these things. Those are skills I think which eventually will come handy, right, when you are in your job. They're not part of the curriculum, but to the extent you can build these skills on the side, I guess that it helps.
It's team lead and not manager. Typically managers have these skills, right? No? Okay. So team lead is different. So we have no managers, there is no hierarchy. A team lead is someone who's more experienced, who leads a small bunch of people and who does equal amount of work as the other people. So that's what you mean by team lead, right?
Yes, a team lead is somebody who has the technical knowledge to assign and evaluate.
Okay.
As a manager in my book only looks at what percent have you completed the project.
Okay. Thanks for the clarification. Naren, you want to say something?
So one part of the question that you were referring to is using cloud or any such external origin, I would call it, system for our defense, let's say. So recently this has been taken up, and in fact IIT Bombay is actually very actively involved in Bharat Jain and that project. And so sovereign AI is something which is coming up in any case. At the same time, referring to the first part of your question, so going forward, AI is going to develop further and further, and these things are going to phase down. Like it happens with any technology when it ripens. Those things will, become. Probably you will not hear about it after 5 years. Maybe AI will be fairly accurate, and these hallucinations, etc., will reduce. But we cannot take risk as far as defense is concerned, and so there we need to, what Shivram was saying about think Indian and make Indian is something very, very important in that aspect.
But for thinking Indian, we have to overcome almost 3 or 4 decades of neglect of the core sciences and core engineering, where we've been sending all our engineers to become software engineers. So perhaps that process can be accelerated, and that's another question we won't go into. But any other question? Maybe I'll take 2 more before we stop. Yeah, we'll go there and to Girish Kotwal after that. Sir.
My question is...
Introduce yourself and then...
As I belongs to academics, I feel rather I would like to get opinion from the Shivram sir and you all as well. Students are getting better engineering, doesn't matter from wherever they are studying, but they also equally has to look into the entrepreneurship as well as the startups. There could be a different sales into the institutions, right? They are the sales. These sales are not directly involved into the academics. They are doing engineering, but somewhat, somebody is having interest into the developing something, they may go into the startups. But rest all, they are not looking at startup very seriously. They are not trying to understand the things that are happening into the startups, even entrepreneurship. And even TRL, technical readiness levels. These people are somewhere lacking into some of these concepts. I believe personally this generation is very brilliant and talented. We need to guide them in an appropriate direction, and we should involve them into all these aspects of startups and entrepreneurship and business and DRL level, so that they will keep themselves ready for industry. So either they could start their industry, either they can have their startup and hire others. So if you people focus on this and guide these audience, so probably they will understand, because being teacher, if we tell them, they will probably not take these things seriously. Thank you.
So may I take my privilege and see, I feel that entrepreneurship is best done when you'll be a better entrepreneur when you have a moat around your startup, which means technology where a richer guy than you can't just run away with it by throwing more money at the problem. Typically we find that moat comes if you have a big advantage of some kind, like say your dad is Godrej and he can set you up with a company, or you have some technology depth where you can have some kind of technology moat which other people can't break, and that's where a master's or a PhD is extremely important. You can build that moat and then go into entrepreneurship, right? So that makes a lot of sense. So I feel that whatever we are doing with these students, it creates that kind of human resource, because I feel a researcher is no different from an entrepreneur. A researcher has to think of new ideas, new problems to solve. Entrepreneur has to look for new markets or where he can deploy this kind of stuff. They have to think out of the box. They have to learn critical thinking, communication skills, learn how to pitch to an investor, or learn how to pitch to Shivram if they want to join his research group, right? So the skill sets that you need in research and entrepreneurship, I feel, are analogous. Okay, so e-Yantra trains you in those kind of things. So we've discovered a way of doing that. And so I feel that entrepreneurship, we are not training these guys to become entrepreneurs and you must be an entrepreneur. Learn the skill sets which are needed to be an entrepreneur if ever you want to do it. And it's better we expose you at this age, because some mental blocks which people have, and most of our blocks in life are mental, the earlier we remove these mental blocks, the better it is. So 1 or 2 years into a job might say, I am bored, I want to do my own stuff, and then you'll go and do something, right? Maybe you'll come back and do a master's or a PhD and then do entrepreneurship. Okay, so that's my response. What is yours?
Yeah, so at IIT Bombay, for example, we do have like structured, as you said, cells. There's entrepreneurship cell, there's incubation, right? All of this is there. I think some number of students formally go through these, they take courses in these different units and so on. I think to some extent that helps. But there's this saying, nothing succeeds like success, right? I think one way to really make all of this happen is for students to see, let's say, the seniors, right, people in the local ecosystem doing something, right, and succeeding, and that tends to catch on. So I think some of this should also happen through informal channels. To the extent possible, you put it in the structure that and there is entrepreneurship because it is new, something that is unprecedented, is sort of like instituted. And I think to some extent it has to happen through students thinking laterally, doing things which are not really part of the system. As instructors, faculty, the thing that we can give them, this is some kind of assurance of security, right, motivation, maybe a little bit of a cushion buffer to let them fail, right, and discover things by themselves.
Good. Yeah, go on.
So I think while entrepreneurship in the sense of starting your own thing is very talked about these days. It's very good if you have a nice idea and a passion to pursue it. But to me, entrepreneurship doesn't necessarily mean that you have to start your own startup, right? So I've worked in small, large startups and multinationals also. Even within every organization, there will be traits and there will be flavors of entrepreneurship that will be looked upon. So for example, this intrapreneurship is also a term, right? There will always be problems. So today, I think whatever you do, you can't afford to be on the sidelines. You have to fail fast, for example, right? Try something, learn from it, move on. Right? So that's a very entrepreneurial thing that, having the right idea, learning what is the value, like pitching to investors, it could be internal stakeholders also. Earlier we used to do so many POCs in my earlier job, and our team lead always used to say, or we used to say, in your application, if it is not in the first menu, don't work on this feature. If you have to click on settings, go somewhere, then pick up to enable your feature, then it's not really that useful for them, right? So how do you build that critical thinking, learn to what is the value of the things that you are working on? So even within companies, there will be things that you can work on. So it's not necessarily that everyone needs to have that startup, but what are the skills and the mindset that goes behind this entrepreneurship that can be universally applied?
So what he's saying is, don't treat entrepreneurship as doing a startup. Entrepreneurship is a state of mind. It's being entrepreneurial. I'm an entrepreneur. e-Yantra is the startup. He's an entrepreneur. He'll take it to its own heights, and he's doing a startup himself. And so I feel what we are all saying is something which is very living and vibrant kind of individual that we want, who's got critical thinking skills, who's a team lead basically, who's mastered technology and can manage other people to reach some kind of goal. So that's the kind of live individual that we want to create. Only time for one or perhaps two questions. We have one from Girish Kotwal who has raised his hand, but we've got two students at the back which I'd like to listen to. If you be very brief, Girish. Introduce yourself and.
This is Dr. Girish Kotwal. I am professor at IIT Vishakarma Institute of Technology. I have, because we have a very good panel intersecting across the aerospace, the AI and defense and so many things. So first I would like to ask Mr. Harshad one question for Dr. Harshad related to why we have been lagging in the aerospace field. Maybe 40-50 years lag is there. When a small company like SpaceX can send a reusable rocket without much help from outside, of course they might have had, but why our big behemoth like ISRO and with the help of other government establishment, we are not been able to do. Of course, even other countries and China and other, many have not been able to do, because your background also is very unique and varied in this field. I would like to know from you what stops all these people as well as India from developing such high-tech things, or even drones that even Iran can be able to use with very small budgets. Why we are not been able to do that? Maybe first with SpaceX and then with the drones, and even others can also answer those.
I would actually dispute that SpaceX is a small company.
I'm talking about when 2016 they did it. Maybe they were quite small, I would say.
Yeah, but
comparatively, maybe ISRO would have been a comparable size at that time.
They started with huge budgets, and our priorities have been different over the past 40-50 years, because as a rule we did not have a huge technological advantage even at the end of the Second World War, which the US and Europe started with. So all the technologies that India has built through ISRO, DRDO, etc. have been built from scratch, from the point of when the light combat aircraft was built. We had to develop the compound for which the rubber is used.
Yeah, maybe today, suppose we start today.
It will happen, I think. It will happen. But I think.
So what are the technological hurdles? Maybe I would like to know.
So Girish, that's a long answer. Maybe you should take it offline with you. We have a few students which we not listen to, so with your permission. So that's a useful start of a conversation, Harshad. So students at the back, the young lady there and the young man there.
Good afternoon, sir. My name is Mayuri Patil. I am from Pune. I would like to ask a question. During the panel discussion, one of the panelists said that in upcoming era, the good engineer will be the one who will have natural intelligence, who knows how to make use of artificial intelligence. During this panel discussion, the only aspect that I could think of or I could figure out is empathy. But what are the other aspects of natural intelligence? Could you please elaborate the idea? Because after hearing natural intelligence, what I could think of was only the intelligence that we inherit or being a topper. But what are the other aspects? Because that is not what is meant for us to become a good engineer. If somebody is not intelligent, but he has or she has deep passion in exploring or in engineering, what are the aspects that he or she should have to become naturally intelligent?
Okay, so what is natural? Do toppers have lots of natural intelligence? That's a question to you, Harshad. Do toppers have lots of natural intelligence?
Many of them do, but it's not the only form of natural intelligence. So empathy is obviously one aspect to it. Another aspect could just be skepticism. So you build an intuition about how a particular system or problem should behave. And if the AI or whatever person gives you a solution which doesn't behave like you expect, you either try to find out where they are wrong, or you try to find out where your assumptions were wrong. So having skepticism, having humility about how much you know and how much you need to learn, these are all aspects of intelligence as well. It's not just academic intelligence we're talking about.
Very interesting. He said humility also, right? Nobody speaks about humility in that sense, of knowing that you don't know.
So one more thing is like if you have heard Professor Harari talk about it very recently, he was talking about the distinction between why humans control this earth. So the one thing that he underlines is cooperation. Humans work with each other, and that's how if one-on-one, if you like a human and a chimpanzee, for example, or any other animal for that matter, we will lose. But still we control the earth. How? So that's because there is a collaboration, there is a cooperation. So that is very, very critical and important from becoming a good engineer. That one quality is something which is...
Thank you. Very important, because that's why we make you work in teams, to show you how to... We find that often people just get their friends into the teams and they don't get anywhere, right? Next year they come back with a proper team, right, with specific skills, and they come to the finals. So thanks. There are many more questions, right? So with your permission, we'd like to go around. I'll take just one more after this and we'll close because we are very late.
So I'm Nishti Mistry. My question is slightly off topic, but what would you say are your views on the moral, environmental and ecological impacts on increasing human dependence on AI? Because with the increasing use of AI, the students and everyone, the cognitive abilities are slightly decreasing. So how does that come into effect with everything that we have discussed here today?
Shivram is the right person to answer this.
First thing I want to say is your question is not at all off topic, it's extremely on topic. This is what we should be talking about. And it is the thing that I think most technologists prefer not to talk about. Right? As though all of this is on the side. In ecology, I don't know how many of you know this, but you're used to LLMs, the kind of large scale data centers that run it need so much cooling and they use up more energy than I think many small countries, right? So we're contributing to global warming every time we use a ChatGPT interaction, right? It happens, I think, beyond our ken. We're not seeing it every time we do it, so we prefer not to think about it. But your generation particularly has to think about it, about human cognition undergoing genuine change because of dependence on technology. Again, there is scientific evidence now that it's beginning to happen. Okay, particularly with your generation, it's been using smartphones. I think that from the time you were the old smartphone. These are all real concerns within the academic sort of community. There are now like sub-communities that do look at some of these aspects. There's a conference, ACM is Association for Computing Machinery, which is like the umbrella body for computer science. It now has a conference on AI, ethics and society. There's another one on it's called FACT, something to do with trust and so on. We're beginning to look at it, but it still doesn't have the mainstream attention that I think it deserves. There needs to be more conversation and I think more action about the side effects, right, which could have a big snowballing effect and which could, in aggregate, I think be harmful. Right? We have to see it coming and we have to do something about it. So I'm glad you asked this question. I don't have answers at this moment, but it is a question that we have to continuously engage with as we go along the way.
Excellent. One last one, because we've not been to... That young man has been holding his hand up for a long time, yellow shirt. Last one. But we'll keep this dialogue going later on.
So, good afternoon to the panel and the audience sitting here. So, I just want to ask that in the contemporary world, there is a term world of AI, how could these solopreneurs build something on their own, like startups or something, by using AI? Like, what are the aspects in the business which AI could help in, and what are the things which one should refrain from? Like, one should not use AI in the process of building something.
Okay, good. I think Harshad would be a good bet to answer that, right?
For a benefit, can you define what is a solo?
Just one chap in a startup, that's it. Everything is outsourced to AI, right?
Not actually outsourced from AI, but he's the only person, he's the team.
He's the team, okay.
No, she's that at work for
Yeah.
So I think definitely there will be a lot of low-hanging fruit that can be realized by solopreneurship, and definitely the pairing of somebody who is looking to solve a problem in a specific domain, who earlier had an obstacle of technology or software or coding, that to some extent will be overcome by them. The success or failure or the impact of that will depend on how deeply the person has thought. So that is not going to change. That is not going to change, right? So whether you are looking for a very superficial level of problem to be solved by leveraging AI, or whether it's a deep. So I feel that even earlier it would have been the same. So really passionate people working on a problem that they are convinced about would have found the means to solve it with or without AI. To some extent it will be accelerated now. The fail fast will happen very quickly. So to be able to get something to see whether or not it will work is now a much more easily accessible tool through AI. So that I feel, but ultimately whether the solopreneurship will mushroom everywhere and proliferate remains to be seen. So that's my viewpoint.
Harshad?
Yeah, I don't think solopreneurship is a new concept. In some sense, an artist has always been a solopreneur, so has somebody like a taxi driver. So because the AI field is so new in this area, how to become successful as a solopreneur is probably something we should learn from other non-AI fields who have been doing this for centuries.
Hey, that's a great point here. You have entrepreneurs everywhere. Your Sabjiwala is an entrepreneur also here. A solopreneur. Right? That's thrown a new spin on it. So these guys have been there from the very beginning. So thanks. Thank you. I hope it's answered your question. The answer was that for doing substantial work, it usually helps to work in teams. But you can do things on your own also, but you might be more limited. AI might make the limitations a bit less, but it might still limit the scope of what you can do on your own. Right? But you're again limited only by your imagination. Please break this myth if you can. Okay, thank you. So I'd like to thank our panel for an amazing session. Big hand. And I think we've all learnt a lot. I'd like to thank them all very much again. So I think we should break now for lunch. Ajit can maybe, he's been wringing his hands, right, saying, sir, you're going very much out of time. But we should take a photo of the panel, right, first? Yeah. Okay, take care.
We'll come forward.
We'll come in front. Please. Shall we look happy for a change? Okay. Thank you.
It will all be edited by AI, so it can make you look whatever emotion you want.
culture of innovation, collaboration, perseverance and hands-on learning that has been built across our ELSA colleges. So for those who don't know, ELSA stands for e-Yantra Labs Initiative, and we are proud to say that they have 600 plus labs all across India. Through e-Yantra, students have challenged themselves to solve real-world problems, and faculties have mentored countless teams, and the institutions have created environments where innovations can truly flourish. Today is our opportunity to recognize and celebrate these efforts. Yeah, so why these awards? These awards recognize colleges that have demonstrated excellence not only through participation but also through technical achievement, innovation, project completion and national level performance. Ultimately, these awards celebrate institutions that have built a strong culture of learning by doing. So we have a lab ranking, so across all these 600 colleges. So the score that they have got this particular year, the last academic year, is being considered for 80%, and all the historical performance of the last 12 years has given a 20% score. Yeah, so we have two award categories as of today. So one is EYRC performance awards. So these are the evaluation criteria. So the metric as it stands, the number of registered teams, the teams who have qualified stage 1, and the teams who have completed stage 2, and the teams who have selected for finalists. So each of them have different marking criteria. Now I request our beloved PI, Professor Shyam sir, to give out this award. Yeah, we'll go down the countdown. We'll start with the third place. So I request student representatives from the college, Dr. Vishwanath Karad, MIT World Peace University. Everyone, please. So they are here to give a short snippet of their success stories and how was their journey. So.
Good afternoon, everyone. So e-Yantra has been a great journey for me. So it started with a single step, that is thinking to register for e-Yantra robotics competition. Myself, Madhav Bangar, and this is my colleague, Ma Sheikh. We are from MIT World Peace University. We'll go through how our e-Yantra journey began. We'll take you through the journey that we went through. The stage one was simulation based. We learned certain concepts, RL concepts, Python programming. Overall, it was easy.
Yeah, so as we all know, the EYRC participants, the simulation phase is always the easy one. And yeah, it was quite a quick breeze, but the real challenges come when we switch to hardware.
This was the graph when we moved from stage 1 to stage 2. Stage 1, like I said, it was easy. When we moved to stage 2, it was like we moved from simulation to reality, and it was tough because for me it was the first experience I had working with the real hardware.
Yeah, so I was in the Krishi Support team, the team that doesn't get the hardware. But the setup that was made for us, like the online setup, that was quite amazing, I would say. Like it was just like we were controlling the robot in real time, but the hardware was in IIT Bombay and I was working from Pune.
Technically, e-Yantra has taught me a lot, like programming, simulation, we can count all those things. But personally, it has taught me patience, like all those countless nights that we had to go through to complete the deadlines for the task. And I know that there were certain bugs that we had to fix. sometimes the code was working properly and other time we switch on the system, it wasn't working. So personally it has taught me patience, perseverance, handling failures and teamwork.
Yeah, so on the technical side of it, I am doing my BTech in robotics, but I came to know about ROS and ROS2 with when I came in contact with e-Yantra and e-YRC. So all these technical skills, I didn't know Python programming before, but all the core robotics stuff like gazebo, ROS, this all I learned while competing in the e-Yantra competition.
And life as an intern here, I'm actually delighted to be selected and given the opportunity to work here at IIT Bombay under e-Yantra as an intern. And personally, it has been a great experience. We can count on the aspects, technical aspects that this internship has taught me, but personally also it has been a great experience.
Yeah, as you can see, it was quite fun for me as well. You can see that pic I am on top of the front gate collecting some video data for our project. So it was quite fun.
And message to the future participants. So in future, we encourage people, we encourage students from the colleges to participate in such competitions, e-Yantra competitions. Even if you are under-prepared, I would still encourage you to participate. Don't be afraid to debugging. Like I said, we spent countless nights solving problems that we didn't knew what the problem was. So still we are debugging.
Yeah, and lastly to add, as he said, most of the people are scared to enter in a competition, and that is only because of the competition itself. But in e-Yantra, you are also taught how to do things from the scratch. In my team, I was also taught how to install Ubuntu itself. So everything is from scratch, so there is no need to hesitate to participate in the competition, and yeah, you should really go for it.
e-Yantra is a great journey, you should explore freely and you should enjoy the journey itself. Yes.
Thank you.
Yeah, I request the other teams to speed up. So without further ado, we'll announce the second place. So second place go to Maharaja Agrawal Institute of Technology, and I request our
So, hello everyone. My name is Yash. I am from Maharaja Agrawal. So, my journey starts from my society. It's our robotics society in our college, Atom. So, in my first year, I joined this society. It was amazing, and they taught me so much. So, every year, our society comes to e-Yantra, and this is the norm now. It's like a festival which comes every year. Our super seniors were there, they were finals also, and as we are. So, about EY SIP. So, these are my friends. I didn't ask for the photo. Anyways. So, as a team, we are working here. As an intern, the learning phase which I came through. So, in the starting, we always happens we think about it and just make architectures, designing, and in my project particularly, we are exploring so many repos and so many open source projects and designing the architecture from the ground. And it was very amazing to work on this project. I am very happy to have this project in e-Yantra, because in e-Yantra and as well as in intern. So the implementation phase comes when we are just filling this gap from the theory part with the architecture and the reality. And at the end, we are binding everything. And there was this workshop, ROS workshop, and it was amazing. So these are the skills I have learned here.
cloud backend, of course, and open source tools, exploring so many things. So what kept me motivating is this. The more I learn here, the more I know the things which I don't know here. So the curiosity always become addiction for me, and it was very amazing. So I want to conclude. It was for everyone here, come to Yantra, and it is like a whole experience. It's not a competition; it's an experience. For 6 months, it's like everything you learn and see. It's like an industry level thing, and it's a humble request for professors and mentors at IIT Bombay. Please start a lab in our college. We want it, and we are just thank you. So this is our lab. You can see, we go to everything. This is the drone thing which I am doing, and the maze solver and the other projects. So this is a lab which looks like a real mess during the competition, and he used to work a lot.
When he said it's a society, he was not kidding. So it's the only other place where all 6 teams are there other than e-Yantra, I guess.
Yep. So we worked together here, and it was amazing. We just used to work from the morning from 7 to the late night 8, and the college supports us totally.
And I think it's time for our first place to give us the awards, and you will know why they are in the first position when they all come here. So the first place goes to SSN College of Engineering.
This is the full cricket team, huh? Who's the captain?
Since we are in startup time, we will complete our tasks. So we are like a group of 9 who are doing internship here. So we are SSN College of Engineering, Chennai, Tamil Nadu. So where all began? So there was a club in our college which focus on embedded systems and robotics, named Build Club, which organizes workshops and events like line follower, maze follower boards. So we gained interest from that. After that, our seniors guided us and showed there is an event named e-Yantra, and you can participate in that. And we, EEE and EC students and MEC students from our college collaborated with each other and registered maximum teams here. So this is where all it begins. So first round, you all know, it is the simulation round. We participated in crop drop, maze solver and Krishi balancer, and these are the images of the simulation tasks. And so going to the hardware round, so we got 7 teams in May. We got hardware around 7 in maze solver team, and 5 in crop drop team, and 1 in Krishi balancer team. So these are the tasks, and these are the bots, and these are mainly made by second and third years. You can see EEE and EC people. So These are the main solver boards. So the center one is the Krishi balancer board. So the two things which I need to say is like from these many teams participated, only one came to the finals. If there was more awareness and more timely support from our college, means more teams could come to the finals. And the next thing is we had many reasons to quit the competition, but we sustained and trusted the process, and so we are finally here in this internship and exploring new things, and the mindset which we had in our college has been shifted after coming here.
So hi, so I'm going to talk about how e-Yantra became the turning point in our lives. So this 6-month journey was nothing short of challenges. From the simulation round to the hardware round, we had to familiarize ourselves with different toolkits. We had to balance academics. We had to attend classes till the evening, and then we had to do the competition at night. So there were many sleepless nights, just like how all other teams put in their effort. So we did all that, and then we came to this destination of the internship program. So people usually say enjoy the journey, the destination doesn't matter. But for this case, both the journey and destination matters. So, so here after the competition in the internship, we found out this to be very different from the other IIT summer interns, which is very much focused on research and a small team and stuff. So here you're exposed to a lot of projects, multiple disciplines. You have people working from mechanical, EEE, electricals, electronics, chip design, etc. So exposed to all kinds of projects, and this opened up ourselves to a lot of different disciplines at a time. So the most important takeaway from this internship for us was the growth we've had, both in technical, social and analytical skills, which has made us more industry ready, is what I'd like to say. So a final note is that we were encouraged from a position of trust. Our seniors had instructed us to, or insisted us to participate in this competition. So we are also doing the same. We are also insisting our juniors to participate in this kind of stuff. So I urge you, professors of esteemed university who are present here, to urge your students to also participate and support them in a timely manner, so they can experience this once-in-a-lifetime experience. So yeah, that's all from my side. Thank you.
So now we are moving on to the next category of awards. So it's UIC Performance Awards. So these are the evaluation metrics. So the number of registered teams, proposals submitted, video submitted of the prototype development, and regional finalists and national finalists. So without further ado, we'll go the same. So we'll go down the countdown. So the third prize goes to Vivekananda Education Society Institute of Technology. Yeah, we'll give them a big round of applause. Although the team could not be with us today, we extend our heartfelt congratulations to them and wish them all the success. Now we'll move on to the second award. So the second award goes to Progressive Education Society's Modern College of Engineering.
So you can say, my e-Yantra journey starts from one session that conducted by my seniors. Under e-Yantra lab, my senior conducted a session introducing e-Yantra to us. And I think that one session was enough to create a curiosity about robotics and solving real world problems. So later I get a chance to be part of EYIC, e-Yantra Innovation Challenge. And my team and I was trying to find out a problem, and we found dozens of problems that are in agriculture, but we come up with one problem that is close to our house, that agriculture worker feel a chronic back pain in their back. So we think of making something
but we don't know exactly. So we come up with a solution, making a passive exoskeleton for farmers. And we know they can't afford a power solution. So we keep it simple, like no battery, no motors, no electronics. We just make a mechanical design that support their body structure using their own momentum. So that is our solution. And our persistence paid off at national finals here at IIT Bombay. We won Social Impact Award. And I really say the award and the title is not the thing that stay with me most. It's the realizing that a student like me can make a thing that genuinely help people. And I want to say thank you, e-Yantra, that gave me that much confidence. And after that, when EYSIP comes, I apply, and now I am the intern here. I work on the project called Scalable Multi-Arena System for remote robotic practice. You people must visit the stall. I think, say, from one session where I don't know who I am, to come a national award, and here I am making infrastructures for next year students who do all the things like control remote robot lift. That's all my e-Yantra journey. And there are so much students here and coordinators also. I want to say just push your juniors and your students because they might sit in the station that I was, that I don't know. Your one push can make them an innovator, researcher, or maybe a e-Yantra, next e-Yantra interns. There are one more team.
Hi everyone, I am Pranavi and with me I have my teammate O. So Akshay mentioned that it all started with that one session. But for me, honestly, it started way before that. I used to see my seniors working on their e-Yantra projects, and at that time I was like, okay, this is something very interesting and cool, and definitely I want to be part of this someday. So yeah, I got the opportunity and I participated in EYRC. So our project focused on reducing the post-harvest losses in tomatoes. We built a wall that monitors the storage condition and try to automatically maintain the ideal environment to increase the shelf life of those tomatoes. So yeah, during our research and validation phase, we interacted with a lot of farmers, and I still remember we used to go to the vegetable market at 3 a.m. just to closely observe how the trading and the transportation things actually happen. So yeah, these kind of experience taught us much more, and we learned from different aspects, and I would say that the whole e-Yantra journey changed my perspective on the engineering. So I would like to request all the professors here that please encourage your students to participate here, because I truly believe that e-Yantra can be a transformative experience for many more of the students, just like it was for me. So yeah, thank you.
Yeah, I think it's time for our last and important award. So the first place. So the first place goes to Ramarao Institute of Technology. I request both the faculty representative and the student representative to comment on it.
So yeah, hi, I am Janvi, and like everyone know their path, I did not know what I wanted to do. So I started with my career in NCC, so that was a kind of defense, so I was into defense, but then I somehow ended up in engineering, and then I met my mentor Sanjeevi Chamote ma'am. So she showed us a path, and that path was EYIC, which is e-Yantra Innovation Challenge. And during that we built a product called AgriUp. So during that stage we discovered the people's pain point, and that process was something that struck my mind that this is the path which I should follow. And yeah, this was the journey I did, and now I am interning at e-Yantra IIT Bombay. So it's been a great pleasure to be here, and yeah, we also visited the naval dockyard, so yeah, it was a great pleasure.
Okay. My name is Anju. EYIC is the most enriching learning experience of my whole academic life, because the initiative of EYIC I like very much personally, because it is the innovation challenge where we build a product from the base. Like we are identifying the problem statement from the ground level. Moving to this year was the theme agriculture. So we have gone to the different farmers and figure out what they actually face every day. So I especially like we had a workshop where we can identify the valid problem statements, and having one-to-one mentor sessions, that I really like the process of EYIC, because it gives an insights how we can build a better solution instead of focusing on complex solution. For complex problem we can have easy solution. So from building the whole problem from problem statement to the app, but now as a final year student we have product. We earlier from the third year we didn't have anything strong to showcase, like we have done something big in our college time. So I think from scratch to the problem statement, we have built a solution which is right now on the Play Store. So we have created a product. So I feel really thankful to the e-Yantra team for starting this initiative, and special thanks to our Professor Sanjeevani Chalapodi.
I think we can close with this. To every student who dared to innovate, to every faculty member who guided and encouraged, and to every institution that believed in experimental learning, thank you for making the e-Yantra ecosystem better and stronger. Thank you.
Thank you, announcement. So after lunch, we will have the certificate distribution ceremony for the women in robotics participants by 2:15.